I will start the recording as well. Recording to the cloud. Okay, all set. Welcome everyone to the Silicon Valley chapter of IEEE Computer Society event. I'm the chapter chair, Vishnu Pendyala. Ours is the largest chapter in the Silicon Valley section of IEEE with over 3,500 subscribers in our mailing list and a strong following of over 12,300 on Twitter alone. We are uniquely positioned by the virtue of our location and available expertise. And thanks to virtual meetings these days, we are able to avail of expertise from all over the world, like in today's conference. So we started ICADS 3 years ago, and today's event is the third in the series. Today's event is also co-hosted by 11 other chapters or sections in the United States. So I'm pleased to announce the active participation of Montreal section, Fort Huachua, Tucson, Phoenix joint chapter, Lone Star section chapter, San Antonio, New Jersey Coast section joint chapter, Hawaii section chapter, San Diego section chapter, Northwest Florida section chapter, Kitchener Waterloo section. So we have some chapters from Canada as well joining, co-hosting this event. And Conestoga College Institute of Technology and Advanced Learning. It's a student branch. And we have the Richmond section chapter and the Richmond section itself co-hosting this today's event. So we have a wide variety of cutting edge topics for today for discussion. We have topics like quantum gate neural networks, AI and social media, which is a panel discussion. We have accelerating code contribution with intelligent semantic search system, then digital twin in aerospace supply chain, enabling performance efficient Gen AI at the edge, and a discussion on the power and perils of generative AI, providing a realistic perspective. So we have a very packed agenda, so please stay tuned. And I now hand over the conference to the Master of Ceremonies for today, Sumit Gerela. Sumit is a passionate iOS application developer with over 10 years of experience in iOS application development and is currently with Apple. Over to you, Sumit.
Hello, good morning, everyone, and thank you for joining. And we are very excited to be having this conference today. We first welcome our speaker for today, Dr. Siddharth Bhattacharya. Dr. Siddharth Bhattacharya earned his Bachelor in Physics, Bachelor in Optics and Optoelectronics, and Masters in Optics and Optoelectronics from University of Calcutta, India in 1995, 1998, and 2000 respectively. He completed his Ph.D. in Computer Science and Engineering from Jadavpur University, India in 2008. He is the recipient of the University Gold Medal from University of Calcutta for his master's. He is the recipient of several coveted awards, including the Distinguished HOD Award and Distinguished Professor Award, conferred by the Computer Society of India, Mumbai chapter in 2017. The Honorary Doctorate Award from the University of South America and Southeast Asian Regional Computing Confederation International Digital Award ICT Educator of the Year in 2017. He has been appointed as the ACM Distinguished Speaker from 2018 to 2020. He was inducted into the People of ACM Hall of Fame by ACM, the USA in 2020. He has been appointed as IEEE Computer Society Distinguished Visitor for 2021 to 2024. He has been elected as a full foreign member of Russian Academy of Natural Sciences and the Russian Academy of Engineering. He has been elected a full fellow of the Royal Society for Arts, Manufacturers and Commerce, London, UK. With that, I hand over to Dr. Siddharth for this great talk.
Thank you. Thank you for the nice introduction. Hope I am audible to all of you.
Yes, we can hear you fine.
Let me share the screen first. Is the screen visible?
Yes.
Okay, thank you. So thank you again for giving me an opportunity to share my little bit of learning experience on this particular topic, quantum gate neural networks. And also thanks to the organizers for organizing such a conference, highlighting different research perspectives in the current context. So this particular topic, actually speaking now, people are speaking very much about this quantum computing, and people are also thinking of implementing them, as well as coming up with different advancements with the quantum computing technology. Thanks to all of them. So this is a small idea or overview of how to implement these neural networks, which you already know from our from our early days, that these are very intelligent in nature and they can mimic the human brain. And given the advancement in generative AI and all other things, so this learning process, the supervision of the neural networks has caught attention over the years. So this particular lecture is targeted to just delve into the realization of neural networks using quantum circuits. So as we move on, the agenda of this lecture will be starting or touching upon the classical neural networks, only a brief overview, followed by the TensorFlow Quantum, that is the framework for quantum machine learning, and then Circio, Google, which is a Google initiative, a Python framework for programming or other for realizing quantum computing circuits. And then it follows with the parameterized quantum circuits, or PQCs, which are actually the backbone of quantum neural networks. And followed by the training model, how these quantum neural networks are trained, and then into the higher level PQCs, a more complicated one. And then finally some optimization techniques which are required for this, for the optimization of these parameters in these PQCs. Just hold on. These PQCs over here, they are parameterized, and so you require some sort of optimization of the parameters to get the best possible results. And some examples touching upon quantum variation and autoencoder and some advantages.
So Dr. Bhattacharya, put it in slide share mode.
This is slide share mode. I don't know whether it is being. I'm scrolling the slides one by one. I don't know what is happening, but then in any way, it is already slide share mode, sir.
Oh, okay. Maybe it should be shared other screen then.
It is the second slide. It's the first slide, and this is the second slide, and it is the third slide. Is it changing it at your end?
No, this is, we are still seeing the second slide, agenda.
I don't know, but then I am already sliding it.
So
Let me
you should
just
be sharing, yeah, you should be sharing the other screen. If you look at share,
hold on. Let me stop sharing. So you see, I am trying to share again. Let me just.
yeah, but this time please share the window where,
Yes, I'm sharing the window itself. You see the slide is being shown, isn't it? The third slide.
yeah, now it is the third slide, but it is
And I
not,
don't know whether it will be moving forward or not. I am moving it forward. It moving now?
no, it is
I don't
still
know.
on the third slide.
Maybe let us move into this particular mode itself, not going into the slideshow. Maybe you have to just scroll one by one. I don't know,
Okay.
there's some problems, maybe technical problems with this in this particular case. Anyway, let me just, I hope this slide is visible to you in this particular mode, editable mode.
Yeah, it is visible.
Okay, let me continue in this fashion only. So basically speaking, these are a small overview or small touch-up or brush-up of the classical neural networks, where you know that you have some inputs and then you have some weights, interconnection weights, followed by, that means then you have a summation process where you just multiply the product, get the product of the inputs and the corresponding weights, random weights, and then you sum them up and also allow a bias to act on these inputs. Then you get some intermediate output U, whereby you apply an activation function, which is a characteristic function of a particular system, whereas whereby you get the output. So this is the general procedure of training a neural network. Now, once you get the output, due to the random nature of the weights, it is not expected that you'll always get the best output, or in the first instance, you'll get the exact output which is required. But then what you do, now since it is a supervised mode of learning, so you have the expected outputs at your disposal. So what you do, you compare the expected outputs with this obtained output, and then you calculate some errors, calculate the errors, and then you use the errors to adjust the weights in using some backpropagation algorithm. So this is all about the neural networks. But then during this process, you require some functions, f, which is the characteristic activation function, maybe different types, logistic function, tan hyperbolic, cos. So ReLU, well, nowadays ReLU is being widely used, ReLU activation function, or sigmoidal activation function, whatever you feel like, depending on the problem. Now, here you see one typical example of a neural network, fully connected neural network, with input layers and output layers and some hidden layers between them. So why these hidden layers are required? Quite obvious that due to the complexity of the problem, if the problem becomes more and more complex and becomes linearly non-separable, then you require some hidden layers to address those non-linearity. And then you get the output layer, and then followed by the backpropagation algorithm. You adjust the weights, and then you again just give the inputs. Finally, in this process, you get some outputs which is very nearer to the expected outputs. So this is the way neural networks generally work, classical neural networks, whereby some equations, characteristic equations are there, where at the output end or output layer, you compute what is referred to as the loss function in this fashion, which is actually the difference between the mean square difference of the obtained output and the expected output. Just hold on. Expected output and the obtained output, you just get the mean square difference. So then what you do, you use this cost function or loss function rather, which is actually the errors are coming due to the random nature of the weights. So what you do, you take the derivative with respect to the weights and try to calculate the gradient with respect to the weights, and then you adjust the weights accordingly. Simultaneously, you also adjust the bias using the same loss function by taking the derivative with respect to the bias. But then the things are quite simple in this scenario. But then if you just go to the quantum neural networks, things are not so simple. And because you do not have these type of mechanisms which can be implemented on a quantum computer, so you require to devise some other alternative mechanisms to implement the same, or in the same spirit rather. So now again, I have just given a broad a quick poster, which is covering almost all type of neural networks, starting from the perceptron Let me just make it more large. I don't know whether it will be. So these are starting from the perceptron, basic perceptron, and then to the deep learning models, deep convolutional neural networks, Boltzmann machine, all sorts of neural networks are being shown at a glance for pedagogical purposes. And now coming to the TensorFlow Quantum, which is the framework, Python framework for quantum machine learning, widely used, widely known. And if you're interested, you can go to this particular link and can get the details over there. So what actually TensorFlow does, TensorFlow actually allows these researchers to use this Google's quantum computing framework from the TensorFlow framework, using the TensorFlow framework. So TensorFlow uses, applies the algorithms on quantum data, not classical data, and tries to build some hybrid quantum classical models. So you have some classical as well as quantum together, because why? Why at all it is required? Why would you require classical as well? We'll be just dealing with that in the later slides. And then you just use these algorithms to develop these classic hybrid models, so that you can get a flavor of this the same type of neural networks or same type of classical machine learning algorithms in the quantum domain. So this is a overview of the TensorFlow quantum framework. So you see, interestingly, here you have both this classical and the quantum, classical data as well as quantum data. So as you know, in classical data, you deal with integers, floats, and strings, whereas you in the quantum domain, you would use circuits and operators. And then you have the TensorFlow Keras models, which actually combine these two, classical data and quantum data together, so that you can use them in the layers below. So here you have the TF layers, TensorFlow layers, to act on the classical data only, and TensorFlow quantum layers acting on the quantum data, and the TensorFlow quantum differentiators. And then vis-a-vis, you have the TensorFlow quantum operators over here, where you have TensorFlow operators for the classical data. And this classical part is being executed on the TensorFlow execution engine, whereas this part, the blue part, are being the quantum part are being used or executed on TensorFlow quantum QSIM or simulators, which actually tries to fuse or combine the outputs of several quantum gates and quantum circuits. And also you have the circuit, already we have just mentioned, which is a Python framework from Google, which is used to realize quantum circuits and quantum algorithms. And then you can implement them either on a TPU or GPU, CPU, or QPU, as the case may be. So you see that is the entire framework is actually not a pure quantum framework. It is a hybrid framework comprising of both the quantum and the classical domain. So now coming just touching upon the circuit, it is a open source framework for invoking quantum circuits. So it has the basic structures like the qubits, the gates, circuits, and other operators for the quantum operations. And you can just use these particular components to develop your algorithm and then run on a real hardware, quantum hardware. So it enables the researchers to design algorithms for the NISQ machines, which are quite prevalent nowadays. So now, what about Circu? Circu is actually, I already told you, Python software library. So it helps to realize and optimize quantum circuits. So details can be found in this particular link if you just go and visit if you're interested. Now, just to give I will try to give one example to will be just clear to you how actually this circuit works. So it is a simple code example. Sorry. So coding is similar to C#. So you see, you just import the circuit library. You just pick a qubit. You just realize that qubit is there. Qubits are there. You just choose a qubit. You just picking an instance of the qubit by qubit is equal to circuit from the circuit library. Circuit.greet qubit 00. So just give the inputs as 00 for classical data. It gets converted to a qubit, and then it's stored, or rather this becomes a qubit itself. And then you create a circuit, quantum circuit. Again, give a variable is circuit, which is given by from the circuit library. You are calling the circuit function with the parameters. What you are doing in this circuit, you are applying a NOT gate and a square root of a NOT gate. So X is a NOT gate, a typical poly X gate in quantum computing, where you apply that X on the qubit, and then you raise it to the power 0.5 means square root. So you have just what you're doing, you're just taking a qubit and just applying a square root of a NOT gate on that. So it's a simple circuit, and then what you do, you just measure what is coming out. Measure the qubit using the key M is measure. So you measure the qubit. And once you measure the qubit, you can print the circuit like this. And then now if you want to simulate the circuit several times, you run the circuit several times to see the output. Because you know in quantum computing, since it is indeterminate in nature, you have to run the get observations on several times, and then you take an average expectation value. So you have you have to simulate the circuit several times. In this case, you repeat it 20 times. You again recall or you invoke the simulator from the circuit library, and then you run the circuit, this circuit already which has been defined before, with how many times? 20 times. And then finally what you print the result. So when you print the results, you are printing actually the measurement result of the qubit for different instances. And now what you do at the end of the day, you just go for summing up or another, taking the expectation or average value of these results to get the final output. Now this is giving this background of the circuit and the TensorFlow framework. Let us see how actually you can realize and visualize a quantum neural network. So the interesting thing is that if you just recollect, in the case of a classical neural network, you have the option of adjusting the weights by using the backpropagation algorithm, that to a classical algorithm, and that is quite easy on a classical computer. But then in the case of a quantum computer, it is not so trivial. So what you require to do, you have to just think of something, or other think of because you know whatever you are doing in a quantum computer are based on gates and circuits only, and some operators are there. Now these gates are actually some matrices, unitary matrices. So you have to just configure or find out some gates or some matrices which are actually parameterized. That means that means the circuits of the matrices can be altered or can be varied depending on a parameter. So unless you can do that, you cannot adjust anything within a quantum neural network. So that is the philosophy behind the quantum neural network, similar to the classical neural network, where you have the provision of adjusting the weights using the errors computed. But here, since there is no provision of adjusting the weights directly as such, what you have to do, you can just only incorporate some variational matrices or variational gates, variational quantum circuits with some parameters, so that you can adjust the parameters and the behavior of the gates will change accordingly. So this is the actual philosophy. So what you do actually, you see in a quantum neural network, structure looks like this, where you have these qubits or qubit array, because you are dealing with several inputs, qubits array either up or down, get psi x in stands for input, and then this is the output. So what you do, you just start the three phases. First of all, you have the quantum data preparation with the quantum data. Now for preparing the quantum data, it is quite obvious, because data is not going to change. Whatever data you are taking from the real world, it is fixed. So you do not require any variational parameters over here. You require fixed gates, like the Hadamard gate or any other gate, NOT gate or poly gate, whatever gate you feel like, or C0 gate or CC0, different gates are there, fixed gates, which with no parameters, because the data has to remain same. So you start with the input data from the real world, which is classical in nature, and then you apply some gates to process the data in the quantum domain and prepare some quantum data. And then once you get the quantum data, you feed that to the quantum circuit learning. Now here, since it is learning process is going on in this particular part, so required to have some gates which are variable, that means which accept some parameterized gates. That is why it is referred to as parameterized quantum circuits. And then finally, after you can, if you have this configuration, and then where you can adjust the parameters of the gates, you finally arrive at some outputs. You measure some output over here. You take the measurement, and then you get the outputs in the real world. But then the problem is that there is no way out to have the backpropagation in this sense, in this particular case. So what you require to do, you have to again do something which is related in the classical domain to process the data, process the output, and then use that output of the classical neural network to adjust these parameters accordingly. So I'll be coming to that afterwards, maybe in the next 2 or 3 slides. So you see, ultimately, this is hybrid architecture. But in this particular picture, it is a purely quantum architecture, where you have the quantum data preparation with fixed gates and then some variable gates where you have the quantum circuit learning, and then you get the output at the output end in the form of qubits, and then you can measure it. Quite obvious. So now for the data preparation, how do you visualize data preparation? Because data is actually classical in nature. Because even though the computer or quantum circuits, quantum gates are quantum in nature, so you have to start with the real, the classical data, and quite obvious also at the output end you also have to have classical data, because otherwise human being cannot understand quantum data. So you start with the classical data. Now mind you, the terminology is such that in this particular slide, all the orange colored boxes are actually quantum in nature, quantum in the quantum domain, and the blue colored ones are the classical data. So you start with the classical data, say some classical data 1000, some data, input data. And then what you do, you are going to convert this data into some quantum data. So what is that quantum data? It is actually Bell state. So what you do, you just simple procedure, you apply a Ramat gate, followed by a C0 gate. Then what you do, you get a Bell state Z0, Z1. So this is the classical, the quantum data. So you start with this classical data, you end up with the class quantum data. So that is the previous part, this is part, you get what you get. And then the next part, that is the processing part, learning part. Again, what you do, you apply some tensor values and some theta values and some poly values, matrices values, what parameters say, and then what you do, you just use these values to find out the expectation or the average, or the average or sampling of the average of these values from time to time, and then also optimize it further to find out whether these combination of values like C sensor, theta, and polys for a particular case is appropriate enough to get the final output, expected output. And then finally you get the absolute or the measurement, and then you get the quantum output. So this is a TensorFlow implementation part, and this is the data flow representation part. Now, involving this, you have different phases. You start with quantum computation tensor. So TensorFlow Quantum has several routines or several inbuilt libraries to you to use to your advantage. You can then quantum compose quantum models. You can add circuits. That means you can develop this particular circuit one by one. And then you sample and expectation values this part expectation values. You can also use this layers.sample routine. And finally, you are quite similar to the classical neural network, where you have to find out the negative gradient of the error with respect to the weights. And also you have to go for some differentiation, finding out the derivative of the loss function with respect to some parameters. So you need some differentiation. So also TensorFlow allows you to, or gives you some permissions for differentiation. And then finally, whatever you get, you just fuse them with the QSIM. Fuse them means you take the outputs of different gates, either the fixed gates or the variational gates, and then you just fuse them to get the final output using a quantum simulator. So now see how the training is actually done. To just recall the previous picture or diagram. So this is a quantum dataset preparation. So these are all fixed gates, V1, V2, and V3. Fixed gates means fixed unitary matrices, where you do not require to change anything, because because it is not possible to change the input, because the inputs are being prepared in the quantum domain in this particular phase. So you require some fixed gates, V1, V2, V3, and then followed by this variational part, where you have this evaluate quantum model part, where you have to just go for finding out a particular combination of phi1, phi2, and phi3, which are the parameters of the matrices U. And so that the proper choice of phi1, phi2, and phi3 after optimization will give you the best possible output. So then what you do the measurement, you get the real outputs again in the classical domain. Then what I was still referring to that, since there is no provision to go for direct backpropagation algorithm or implement backpropagation algorithm directly on a quantum machine, so what you require to do, you're going to have to feed the outputs coming out of the quantum model to some classical neural network. So it's comprising of input layers, serial layers, and the output layer. Then at the output layer, you get the classical value, quite obviously. So now you have a provision over here to compute the error of the system, or the loss function, or the cost function. So then based on this error, what you do, you just feedback that to adjust this theta is a parameter of this particular neural network, classical neural network, which you can change maybe these are the weights or the biases, and this phi 1, phi 2, and phi 3, the parameters of the unitary matrices of the variable gates or variable matrices. So that means you have a provision now to adjust the parameters of both this part and this part as well. So now once you can adjust these, and then again you can start all over again. So this moves on in this way until finally you can arrive at some outputs when you find that this cost function is very low or that loss is very, very small. Then you find that this neural network has been trained properly. So these are the different phases. What we discussed just now, you have to first prepare a quantum data set, then you evaluate the quantum model, then you sample or average that, then what you do, you just go for the measurement, that is sampling or average, and then you feed that output into some classical model. And then from the classical model, you get the cost function, use the cost function to evaluate the gradients and update the parameters accordingly. So as I already just discussed you, the TGFQ, the TensorFlow quantum allows you to, or the gives has some derivatives, differentiator operators to use it to advantage to find out the derivatives of the quantum operations or quantum matrices. So let us see how it happens in the following slides. So now let us go to the higher level, just for a higher level of abstraction, or rather more in the just breaking it down into smaller steps, going to the lowest level. So you start, let us suppose now if you just recollect this circuit, this is the variational part, where you have these matrices with some parameters. So let us suppose that this is the u theta, one particular u theta, which has been measured. Now this u theta actually can be represented as because a single u theta can be represented as a product of several other variational gates like this, v1 theta 1, vu2 theta 2. In this way, you can just represent them as a product of vl theta l. Again, each and every vl theta l can be represented again by can be just broken into subtasks, like with w1 theta 1, w2 theta 3, several other smaller gates, where you can represent each vl theta l as a product of this wl theta l. Now, each and what this w2 theta 2 or w1 theta 1 or this particular wl theta l are, it is actually it can be represented in the lowest form by means of some Hadamard gates, these gates, and some phasor information, which can be represented in this particular form, e to the power I theta due to this phasor, and gz being a generator, which is Hermitian operator. So what actually is going on, because this is the part, if you just recollect, this is the part which is in the quantum data preparation. So from that you get some output to apply to this u phi. Now the u phi can be finally broken down into this particular form, in this particular exponential form, where you are using some Hadamard gates, fixed gates, and some fixed phasor gates, or Z gate, Pauli Z gate. Okay. So for the ease of understanding, so let us see what the mathematics behind is working, how it is working. So finally, after going through all these, you can just simply write down a quantum neural network by means of a matrix like this, u theta, which is actually a product of VL UL theta. VL at the fixed gates and fixed matrices, and these UL at the parameterized matrices. So you see, this is the VL is a non-parametric unitary matrix, and UL theta is a unitary matrix with variational parameters. Because ultimately, what you are doing, you are just getting the output from here, and then coming here, these are being multiplied. The outputs are multiplied, cascaded in a cascaded way. That is why their multiplication has been shown over here. So now, if you just go it further, if you just look at this particular UL theta L, not this one, this UL theta L, again, UL theta L can be represented in this fashion, can be broken down into several other unitary matrices as a product of different unitary matrices. Now, each and every UL theta L, if you just recollect the previous figure, this one, it can be represented in this particular form as an exponential of some generator. So you see, this can be represented as the e to the power I theta L, GL. But GL is actually represented in terms of a poly matrices because you are ultimately applying, it's the lowest level of abstraction where you are applying the poly matrices on the qubits or the quantum data, and beta IL or beta JL, which is actually another another parameter which is similar to the weights. If you just weights in the classical neural network, if you just recollect the classical neural network, you have some summation operation where you have you sum of the products of the weights and the inputs. So here a similar type of expression is being obtained where you have this particular expression with the polyunitary matrices, where you have this at the qubit level, and then you have some beta JL parameter which are acting on the qubits. Now then, if you just go further, you will theta L, then you can represent it as a product of e to the power I theta L, B, J, L, K, and Pk. That is just going to the lowest level. Now, in order to make it in order to differentiate this particular expression, what you can do, you can just represent that in this particular cosine and sine form. Quite simple. Just represent that is a cosine of theta JL theta L and beta JL into identity matrix minus I sine part, which is actually holding the information. So this particular form, this is differentiable. So that means you are now in a position to differentiate this UL theta L with respect to theta, because theta is a parameter actually. So now if you just correlate with the classical neural networks, due to the random nature of the weights, you are getting the errors at the output end. Similarly, due to you do not, because of the fact that you do not know what the exact values of the parameters will be, that is theta L, you are getting some outputs which are producing some losses of some errors in the quantum domain. That means UL should be differentiable with respect to theta L. So theta L is going to be play the role of a weights in the class, similar to the classical neural networks. Now, what is the optimization procedure? Sampling or expectation part. That means you want to optimize the parameters theta, so that the particular set of thetas or particular set of phi's in the quantum circuit will give you the best possible result, which is similar to the expected output. So then what you do, you can just, since you already have discussed that in the quantum domain, you have to take several measurements and then you have to take the average or expectation value. So here also you can just take the expectation value, represent the expectation value in this fashion, like this expression where get psi 0 and bra psi 0 on both sides, the expectation value, and within that you have this U matrix, U dagger and U. So if they conjugate and this matrix itself with the H, this H is the Hamiltonian. Okay. So now this H can be represented in as a product of several operators like this alpha k hk, and then finally you can just also represent that as a alpha k into expectation of the hk, because ultimately you are going to take the expectation value of this expression. Anyway, so now that means you are now in a position, what you are doing, you are now in a position to go for the differentiation of this u or the f. F is what? F is actually the expectation value, because you are not dealing with the single u, because the effect of u on the inputs will give you some outputs. And since you are going to have several outputs on several instances, you have to take the average expectation value, which is now f theta. So f is also a function of theta. So we have to differentiate f with respect to theta to get the adjustment factors for the theta value. Because ultimately our objective is to optimize the theta values to get the correct output. So what you do, you go for the expression by using chain rule, where you have eta k is given by theta and beta. So you can just since theta lk is given by theta j beta jk, so what you can do, you can just use the chain rule where del f del eta del theta. Now del f del eta del theta will give you beta. So beta comes in del f del eta k. So this is the expression for this weight adjustment. And then applying that, you can just, I'm not going into details of mathematics. Again, just recalling this expectation value in terms of eta now. In terms of, because we have just converted the differentiation in terms of eta. So you can just write the expectation value in a similar fashion. But in this case, instead of theta, you are now a variable is now eta. We're just replacing that with theta. Now this actually you can just find out that this derivative of this expression will give you something like this, where if eta plus some perturbation factor, plus and minus perturbation factor, which actually are representing the deviation from the deviation due to the error, due to the derivative of the derivative with respect to the eta. So finally, your objective was to find out del F, del eta k. So you have found out del F, del eta k in this fashion. So now actually, what actually happens after you get all these expressions, all these outputs and the corresponding loss function as well as these derivatives. So what you do, you got to use them to advantage to adjust the thetas and the phi's, whatever parameters are there in the quantum neural network. So now just let us see on some example, simple example of how to do that. That means hybrid backpropagation, because you are involving both the classical and the quantum domains together. So just simply you just look at this, because it is a simple procedure. You see, let us suppose that you have a DNN or deep neural network over here, which is giving some theta values. That means in the previous case, we were only dealing with the quantum neural network with real inputs coming from the classical world, and then you are applying a classical neural network. Here, what you are doing, you are using both two classical neural networks in both the directions of the quantum neural network. So what you are doing, you are getting the outputs of the DNN, which as theta j, which are actually being used to as parameters to the quantum neural network in this u theta 1, u theta 2, and u theta 3, which are coming from this neural network. And then it is being produced, it is producing the expectation value hj, what we have just discussed, and then it is being fed to after measurement or sampling. You are feeding that to another classical neural network to get the ELF or the loss function. Now you are taking the derivative loss function with respect to this h, because the h is the expectation value. Ultimately, h is actually contributed by this theta to get the gj. And then finally, what you do, you just take the derivative of gj with respect to theta to find out the derivative of L loss with respect to theta. And then you just feed that into DNN. So ultimately, what you're doing, you are adjusting the theta using this expression. You are ultimately not doing anything on the quantum neural network. What you are doing is, again, that means whatever theta values are being provided from the classical neural network to drive this quantum neural network, you are changing that in a roundabout way, using another classical neural network coming that, and then again fitting that since once you get this the loss derivative of the loss function with respect to theta, you can adjust the theta accordingly. Once you can adjust the theta accordingly, then you send the adjusted theta to the quantum neural network. So the quantum neural network is now equipped with adjusted theta, and then you will produce another set of outputs. Again, the same procedure will be repeated. So you see that means you are doing the same thing by backpropagation in a roundabout way, using the help of two classical neural networks on both sides of the quantum neural networks. So now this is some typical example of the performance of the quantum neural network versus hybrid quantum CNN, classical neural network. So you see it's a QCNN quantum CNN. So this is you see from the performance. This is the hybrid CNN, the classical part only. This is the hybrid CNN with multiple quantum filter. This one, you see the convergence is very fast. If you use multiple quantum filters, but this is a single quantum filter QCNN, this is very slow, not so fast, the convergence is very slow compared to the hybrid CNN, that means the classical part only. But net, if you just apply with some multiple quantum filters, you get a better performance over here. So pure quantum neural networks do not perform well compared to the hybrid ones. Now some examples how to implement or use these to solve real world problems. So for example, if you just want to develop a quantum CNN for images, so quite simple. It is, you see what you have to do, start with the input, and then you find out the feature vector like that, and then you apply some quantum filters. And this is the convolution operation, and then pooling and all these things taking place, and finally you get the output. So now if you just replace what is all about this quantum filter, if you just look at this diagram, you start with the inputs from here, one single block, 2 cross 2 matrix, and then each and every theta, because ultimately these thetas that are going to be coming out from the classical world. So theta is being computed to the quantum domain, theta 1 into 0.4 into pi by 2. You are just converting into quantum domain and fitting that to a rotation gate. In the rotation gate also, you just give some another input, another auxiliary input, or ancillary qubit, which is referred to as a gate 0. Similarly, theta 2, theta 3, and theta 4 are coming from the other 4 quadrants of the matrix. And then what you did, these are driving these qubit gates. That is the variational qubit gates, which are dependent on the theta parameters. So there are multiple quantum filters like this for a single qubit gate, multiple 2 qubit gates. So you may have several different blocks of similar nature, and then you get the measurement, and then finally you get the output feature map. So this output feature map coming over here, this one is actually this one. So this is coming over here, and then you carry out the remaining part in the classical domain itself to get to classify cat, dog, sheep, etc. So you can fit a quantum filter in between, because already in the previous case we saw that this hybrid one with multiple quantum filters is giving you the best convergence performance. So that means you are not doing the entire thing in the quantum domain, you are doing some quantum classical domain, but then the addition of these quantum filters already are giving you enhanced performance in terms of convergence and speed. Now, another way of optimizing the parameters, that is, you can use some classical neural network like recurrent neural networks to optimize the parameters. So some typical circuitry can be like this, where you have few recurrent neural networks or LSTM, where what actually this recurrent neural networks does, it takes the previous state HT1, that is the expectation value of the previous state, and then also the theta of the parameter of the previous state and the output, final output of the quantum neural network of the previous state. And they use these 3 inputs to predict the YT for the next state. And this YT again can be YT, theta T, and HT can again be given to the next stage to predict in another set of HT plus 1, YT plus 1, and YT plus 1 and theta T plus 1. And finally, you can just find out the loss as usual, as we have discussed earlier. So you see, recurrent neural network can be used to predict this, because the LSTM always takes advantage of the previous knowledge. So you can use the previous knowledge like this to predict the future thetas or the outputs or the expectation values. So this is all about it. All now, this you can just visit this link from Pennyland to get some details about this process, the entire process step by step. So this is all about written over here, where you have this recurrent neural network, which also may have, this is a classical recurrent neural network, which also may have some parameters phi. So if you can tune these parameters phi for a particular set of parameters phi for this recurrent neural network, it can take the expectation value HT, the theta T, the current theta T, current expectation value, and the current output to predict the future theta T plus 1 and HT plus 1. And the performance is also shown over here. If you just apply the stochastic gradient descent, the simple one, vis-a-vis this LSTM based, recurrent neural network based optimization, this quantum optimization, that was just been shown in the previous figure, this one, which is a quantum neural network coupled with a RNN. So you see the performance difference. It is SGD, and the performance of the LSTM, recurrent neural network based optimization, is very, very good. The cost function just dips down very fast. So another example, just to put forward to you, you know already this classical autoencoder, what it does, it takes an input and encodes it to get some lower dimensional type of variable, latent variables, also referred to as a feature map, and then you go for reconstruction again to get back the original output. Some outputs which are similar to the original. Now you go for minimizing the difference between the expected output and the original and the obtained output. So this is the mechanism. So you can also implement a quantum autoencoder like this, quantum variational autoencoder. Why is it variational? Because you have to adjust the parameters theta. Otherwise, you cannot manipulate the quantum neural network. So it is a typical illustration where you have these input qubits, and then it just gets reduced to a reduced number of qubits. From 6 to 3 you get, and then finally again you reconstruct or decode it to again 6 qubits. So it is a typical circuit diagram. You start with 6 qubits as the inputs, and then what you do, measure out 3 of them. And once you measure them out, they are actually converted to classical domain, and they are ultimately lost. But you just allow the other 3 qubits to go over here, and just what you do, you just boost them up with another 3 ancillary qubits to finally form the 6 outputs. The typical hardware architecture also shown over here in terms of the variational autoencoder, where you can adjust the parameters of the variational matrix U like this. We having the parameters P1, P2, etc. So you see, this is a reference state because in this case, you have to just compare with the expected obtained output is the reference output. So this is a reference state, Kte, say for example, quantum state, and some ancillary qubit 0, gate 0, and there is some Hadamard combination, Hadamard gates and swap gates to find the this is a reference. That means the reference is being clubbed with some ancillary qubits to find out the cost function, because the cost function is based on the difference between the reference state and the obtained output. Now for the inputs we are giving over here, the real inputs like this, these are the inputs, and then some of them are being moved to trash, similar to here, measured and moved to trash. And on the other state, that is the compressed part, you just go for calculating or putting it to the decoder to get the outputs, finally 6 outputs. And once you get the 6 outputs, you compute the cost function with the help of the reference state coming from here, and then you apply the optimization scheme. Either you can apply any optimization scheme you can feel like, maybe using the RNN or any other SGD like that. To what you are doing, why you are doing applying the optimization scheme? Because we are getting new set of parameters which are being used to for the new unitary matrix which is there inside the encoder. So that actually is done to find out the difference between, that means based on the cost function, you are just adjusting the parameters of the unitary matrix U inside the quantum gate, quantum encoder, quantum circuit encoder, so that in the next step you can get better reconstruction. So finally, some of the different QNN models. You can have the quantum multilayer perceptron neural network, similar to the classical neural network. Quantum competitive, quantum inspired neural, lots of work are going on this particular field. Then quantum dot, quantum cellular, qubit neural networks or associative neural networks. So almost all the neural networks which you know are now having them quantum alternatives, so quantum versions. Also, we have quantum SVM as well. So now finally, what are the advantages we are getting? It demonstrates remarkable capabilities. First of all, you can generalize similar to any neural network, classical neural, you can generalize because these are universal approximators, so you know. These are tolerant to noisy training data, and also absence of Bayesian plateau in the cost landscape function because you are using some optimization techniques. Now finally, to sum up the advantages, you see the advantages are manifold. First of all, exponential memory capacity. Although you know the neural networks also are very highly connected neural network have good memory, but then here also you have the exponential memory capacity. You're having higher performance for lower number of hidden neurons. That means the capacity of handling nonlinearity is higher over here. Faster learning, and most prominent is this one: single layer neural network solutions of a linearly inseparable problems. Now, if you just recollect the classical neural networks, you know the multi-layer perceptron having multiple hidden layers. Why these are required? I already discussed, because in some of the linearly non-separable problems cannot be solved by the basic perceptron. You have to have some hidden layers in between. You have to just introduce hidden layers. But you can see that single layer quantum neural networks can also solve linearly inseparable problems. That is a very beautiful, interesting thing. And also finally, faster processing speed, quite obvious, because because of the superposition principle and other quantum properties, you have this faster processing speed. So that is a small contribution or small overview of whatever I tried to just discuss with you. So thank you very much for giving me the opportunity. Now I am open to any query which you may have in the process.
Thank you so much for the insightful talk, Dr. Siddhartha. Uh, I'm looking at the questions from our chat and in the Zoom link. I don't see we have any questions. I would like to open up to the participants to see if they have questions. You can type it in the chat window, and I can relay them to the speaker. While we wait, I have a little icebreaker for the participants and the speaker. If The little known fun fact about quantum gate neural networks that I learned today was this is a fairly recent domain, and the concept itself was first proposed in 2018, uh, which is fairly new uh, for the research that has been happening in this area. So really insightful discussion.
Hey, please, Smith, please enable the Q&A. I when I'm clicking.
Mhm. Is that something that you can do, Vishnu, on your end?
Yeah, so it says no open questions. I don't see any questions here.
Yeah. I'm not able to, click on the Q&A. It's disabled.
Uh, allow participants to view question. Oh, yeah, sorry, yes. Yeah, now you can do it. You're able to pose the questions? You can also post them on the chat window.
While we wait for the questions, I have a question for you, Dr. Siddhartha. Maybe you can share your insights on what problem would you, if you could build a quantum computer, what kind of problem would you want to solve first and why?
No, typically you can solve any problem which you are just now dealing with classical computers. The advantage is that these are very faster in nature. So, and also that you can also solve NP-complete problems which are unsolvable in using classical computers. Typically speaking, in some nowadays these quantum machine learning or quantum computers are being used in several domains, starting from scientific problems to economic problems as well. So there's no limit to the type and nature of problems. Another question has come up from Mr. Amit Dubey. What type of ML infra you needed for QNN? So these things are quite different. ML infra, in the sense, if you are thinking of infrastructure, this is a completely new domain altogether. But traditional machine learning algorithms can be recasted into some quantum versions, and then you can just use it for any sort of data, maybe either a big data or any other. Because the advantage of quantum computers is that you can process data in parallel fashion. So you can just have a huge amount of data. Data size doesn't matter at all. The only thing is that matters is how you just modeling your algorithms in the quantum computer.
So on the YouTube live, there's just one comment. Somebody sent, Sarth Gupta says, hello, sir, I sent you a connection request on LinkedIn. I'll be grateful if you accept it. So that's the only comment there. So no questions on the YouTube so far.
Anyway, can we just wait, or other we can dismantle, because maybe we have to have this next speaker online. You have my email address. You can send any query if you have, or if you want to collaborate, we can collaborate together as well.
All right. Thank you so much, Dr. Siddhartha, for this insightful talk. I would now like to hand it over to Shreyasi for the next panel discussion.
Thank you.
Hey everyone, good morning. We're just waiting for two panelists to join us. Just give us a few minutes. All right, meanwhile, the panelists are joining. Let me first give an introduction and then we can begin our panel discussion. So yes, good morning, everyone. And we're so glad and so honored to be with all of you today morning. And our main discussion topic today is the convergence of AI and social media. So as we know that the recent emergence of generative AI has brought forth new challenges related to IP rights, privacy, and data protection. Our goal is to shed light on the timely and cutting-edge issues on the intersection of AI and social media, thus ensuring that the integration upholds principles of justice and fairness. So as we know, in Facebook, in the year 2024, we have around 3 billion monthly active users. YouTube has around 2.4 billion active users. WhatsApp has around 2 billion, and so forth. So as we witness the remarkable capabilities of generative AI models like ChatGPT, DALL-E, and Midjourney, among others, they create wide range of content with remarkable ease and speed. It begs the question, how does these models impact intellectual property rights, authorship, and consent? So together with our four panelists, we'll begin our discussion. Let me just see whether all of them are there. Aksa is here. Professor is here. Vipul is here. I think we're just missing Meenal. Yeah, give me. All right, so let's begin. All right, so I wanted to start with introducing the panelists. And we have Professor Anupam Mukherjee, we have Vipul and Aksa. So I would ask each of the panelists to introduce themselves. And also, I have an icebreaker question for you. And the question is, what is the most fascinating aspect of social media for you? So over to you, Professor. I think you are muted, Professor Anupam Mukherjee.
Yes. Can you hear my voice? Okay. So thank you all of you for giving me the opportunity. And as the questions, what is the fascinating point or aspect of the social media. Just like the first point is the connectivity. Just right now, it is so the social media's ability to connect people from all over the world is just one of the first fascinating point. Second is just like the real-time information sharing. That is the instant sharing of our views, latest news, certain ideas, and everything at a rapid speed. And then from my aspect, the community building is another important part, because in social media capacity to create the online community around the world is really interesting as well as unique. And the influence and impact of the power of the social media influencers and the content creators to shape opinions, trends, and different cultural narratives is another aspect. And constant evaluation. The social media rapidly evaluated with new platforms, new we are using for the different aspect like chatbots, and for like for different like when I booked the doctor's appointment, I just use the chatbot, or say just for the booking of any foods, like in India, Zomatos and all these are easily available. And day by day, by using this AI technology, it is really interesting. Thank you.
Thank you, sir. So moving over to Vipul. Vipul, would you like to introduce yourself and the icebreaker question as well?
Thanks, Shreyasi. Hi, everyone. My name is Vipul. I currently work with Netflix as a data engineer on Open Connect streaming data engineering team. Uh, so for me, I think what Professor mentioned, I think again, it depends upon how you look at social media. For me, I just look it for fast information around the world, because now with reels and a lot of things, I think sure, like there are a lot of content, but again, the recommendation is very efficient. So it depends upon what I'm interested. I just get all that information I want, and also I get a chance to see what my friends abroad, who I have not seen in last 10 years, are doing. So I think it just gives it feels me connected. I think that's the power.
Great. And over to you, Aksa. Thank you, Vipul.
Thanks, Tracy. Hey, all excited to be here. My name is Aksa. I'm a product manager at Google focusing on ads measurement right now. And one of the exciting things about social media to me is like the organic connections it helps build. To give you an example, there was a tech fest earlier this week in San Francisco. Of course, I'm based out of LA, and I wasn't able to attend that in person. But a lot of founders and entrepreneurs were traveling for this tech fest from UK, and just organically through LinkedIn, I was able to read a lot of posts, connect with them, and have a conversation in the subsequent, like in these coming weeks. And I don't think this would have been possible without like social media, or like the fact that we have so much information about them. And like this one is specific to LinkedIn, but I'm sure we have more examples around even like Instagram and Meta and WhatsApp, creating a lot of these organic connections in order to like learn, grow both professionally, personally, and pursue hobbies and interests. So in my opinion, that is a step change function there.
Cool. Yep. And we have Meenal as well. Meenal, would you like to introduce yourself and the icebreaker question as well? Thank you, Aksa.
Sure. Hi, everyone. I'm Meenal. I'm a product manager at Meta. I currently build multimodal models for Meta AI, which is the virtual assistant at Meta that you see on Instagram, WhatsApp, and pretty much everywhere now. I think the most fascinating aspect about social media for me personally has been about community building and finding those niche communities that you can really connect with. So, for example, whether you work in tech, or whether you are a woman in tech or a mom in tech, to me, finding those like-minded people, or whether you're a hiker, you can find a community on social media and really connect with them and engage on topics that are of interest. for you, which is true. I would say not just for Meta's communities, but even when you look at Reddit, to me, like that has been the most fascinating aspect.
Nice. All right. So, so we have a set of questions with us, and we'll have that discussion within our panel. But of course, the audience can put forward more questions on the chat or on the YouTube, and we'll take it up as and when like we read that information from the chat or the YouTube. But let's begin with our first question, and it's mostly on the benefits and impact on the convergence of AI and social media. So I would put forward this question to Professor. How has the integration of AI improved audience analysis and content optimization on social media platforms?
Okay, from my point of view, AI powered different analytical tools are already there. They are actually getting the detailed information about the audience and their demographics, their interests, their behaviors, and this actually enabling more targeted content creation. Then the prediction, many predictive algorithms are already there. AI can analyze the historical data and the video content and focus the different viewship. Then it will assist the creator to adjust their content strategy. And like sentiment analysis, this is another part in AI analyze audience sentiment, which allows creators to adjust their content and strategy to better resonate with the audience. And AI algorithms can detect the emerging trends and topics, as well as AI can pinpoint where the viewer lose his interest in videos or articles. That helps to adjust their content. And these are some of the points. Apart from that, AI can also forecast the how many likes, shares, comments, and other engagement metrics are there. That actually really helps the creator to adjust their content strategy. And apart from that, another point from my aspect, that is the NLP, natural language processing, that enhance the social listening and allowing for accurate audience analysis. These are the few points I have. And like different chatbots and automated captions that also enhance the user experience.
Yeah, definitely. I think AI plays a huge pivotal role right now in enhancing the user experience. So I'm curious, like as a product leader like Meenal or Aksa, what insights do you have regarding the integration of AI technology into the products that we use for social media platforms? Anyone, Meenal or Aksa?
I think in terms of kind of how AI is getting integrated into the social media platforms, to me, it's like AI has been a fundamental part of social media platforms actually throughout its evolution. We are now, I think, focusing more on generative AI, but if you think of how these platforms are built, when you're bringing a large group of people together, just being able to identify the right set of recommendations, the right set of things or posts, for example, to surface to the people, it is all powered by AI. So to me, AI has been a fundamental part of how things have worked so far. I also think with generative AI, things will shift, and with AI becoming more and more, with evolving more and more, things will start becoming more advanced, where some of the things that were earlier touched on, like sentiment analysis, being able to actually see, let's say AI gets the ability, like vision capabilities, which is going to come with generative AI. Can it actually see what's in a video? Can it actually see what's in an image and understand the sentiment, understand the voice and the tone of the user, and really then help you better interact with others on the platform? So I think that those are some of the things in which like AI has been a part of some of the backend systems, I would say, but now it's going to really make its way into the front end systems and help you learn more and gather more information.
Yeah, that's a good point. And like the UI experience, exactly where the user comes into the picture. So I'm curious, like how conversational agents, like we know about chatbots, and we also have been hearing about social media bots. So can you explain a little bit more about how the sentiment analysis, the methodology works with these kind of social media bots?
I
Or
think,
anyone in the panel? Yeah.
yeah, go ahead.
So I can help add to what Meenal said, right? There's a various angles to look at this. And traditionally AI powered recommendations, personalized recommendations has always been in building these super curated experiences on social media. But when it comes to like behavior analysis or sentiment analysis, a lot of this conversational AI is based on the or exact choice of words. When you are having this back and forth conversation with the agent, is able to capture through all these different modalities, whether it's your text-based inputs, whether it's images, whether it's videos or your audio you are chatting with, your tone, your choice of words, your length of sentences. All this helps evaluate, especially like the media. Video is a very rich form of video, with like a media where it is able to not just capture like it is not able to just capture like signals around the content, but also your facial expressions, your tone. If let's say if the entire images are available, then your like walking gait, speed, and all of this to say it has a lot more information about you, that helps understand your sort of right the context and the behavior that you're doing now, and predict what it will do in the future. To give you a concrete example, in recommendation systems we use user behavior like clicks and interactions, whether what you purchased, what you not purchased, but that is sort of limited. But with multimodal content like videos, now we are able to go much further into like your entire actions, like in examples of like for an example, like I worked on a behavioral event analysis application, where the entire image of the person walking into the room, we're able to extract the sentiment, their gait, their speed, their body language, and look at a lot of these signals to extrapolate, Nate, what are you just doing now and what will do in the future, to be able to provide additional personalized signals. So let me pause at that.
I'd also just add to what Aksa said. I think sentiment analysis really, like, unless it's explicitly given by the user, just being able to, for the model or for like AI to see the user or hear the user and do that analysis is still very early in where it is. I think where it's headed, a very good example of that would be if you look at GPT-4o's demo and how you when you actually even try to talk to the agent, to the conversational agent, it's able to sense from your tone how you are feeling. It's still in beta phase, it's still not fully rolled out, but to me that's kind of the direction where it's headed. But I don't think it's there. It's still very early.
Mm-hmm. Yeah, so we are in those early stages of the AI development. And I'm also curious, Vipul, what are your thoughts on this one?
So I think Aksha and Meenal have spoken about goods of AI. I have a very mixed feelings, and I'll just give examples, right? I mean, AI is definitely good. It's super powerful. It helps me make me productive of my work. But I think now is the time to start policing, building technology to police AI as well, and control the narrative of AI as well. For example, any part of the world, right? Like anyone can use like just mock me and do whatever with my face. I think it's all the technology is already there, and in 5 years or 10 years down the lane, it'll just get more and more worse. So I have a kid. When he grows up, I think that the world will be very different that time. So that worries me a lot. Like even social media, and it's so much open, and the models are so open. So for me, in my mind, I think what part of AI should be open and what should not be, I think, is what we need to solve, and it's a hard problem. Internet is open, it's a very hard problem. That thing. Another example is like simple example, like you're interviewing. Everything is remote interviewing, right? So now with the events, AI become more and more efficient. Like uh, it's easy to even from hiring to every part of our life cycle can lifestyle can be affected with that. So yeah, so I see a lot of good, but I see a lot of bad as well. So I think uh, good can be done, but it's very hard to control the bad piece. So that's my view of it.
Definitely, this reminds me of when the internet search was developed by Google, and they had a way to opt out of indexing pages, but right now we don't have, or I'm not aware of whether our information can be really private or not. So yeah, that's a major challenge. Yes, but thank you all for putting your thoughts into the benefits. We focused on the benefits, but right now we'll understand what are the challenges that different organizations are facing in implementing AI, because all of us, we want to use AI as a partner or a collaboration tool, or you can say somebody, like for example, even the AI algorithms, they need inputs, and those inputs are human generated, right? And then we can get better outputs or more modeled outputs that can be used for different purposes. And also the organizations rely on AI technology to understand what strategy they can use for marketing, for branding, for different purposes. So the question is, what are the major challenges organizations are facing when implementing AI technologies to combat misinformation on social media, which we see a lot these days? So anyone can take up this question and we can start.
So, can you clarify misinformation on social media? Is it specific to like uh, every organization, like for example, like a organization like Meta, or is it like just very generic XYZ organization like trying to solve this problem?
I think it's a generic one, and misinformation means, for example, like a certain text or a certain image can be also augmented, and to make sure it aligns with the company's objectives. So there are different use cases like that where we are augmenting different resources. So what challenges the organizations are facing while implementing some of those methodologies, or um, uh, are there something which, or what are the trends that are happening and what challenges organizations are facing is what the question is.
So I can talk about one of the challenges which I see, and I think uh, this is not with the technology. I think the biggest challenge what I see is happening, at least with the medium to smaller size tech. AI is expensive. It's very expensive to implement it right, and to justify the cost of implementing with the GPUs and like all those stuff, right? And you need to like so let's say like even image processing, like you need to process an image, you need to train like sure the models are trained, but you still need to provide a lot of data, and the compute is super expensive, I think. So yeah, that is the biggest challenge, and we don't know, right? Like if after spending billions of dollars, it's possible that you might not get the return as of now. It's possible. I don't know, like 5 years down the line, it will definitely be like we have to wait and see, but I think that's what I see. A big barrier or a challenge for any small to uh, mid-size tech company or any firm, I think, or a small news company, XYZ, who wants to solve it.
So we are talking about return on investment, whether if we invest so much, then
Yeah.
what return on investment in the short term, in the long term. Yeah, that's a good point. Any
I
follow-up? Yeah, Meena.
I can add some challenges that we face now that we are building these language models. I think the top three challenges that I'm seeing, and of course there's deployment, there's cost, but the top three challenges that I'm seeing are data, privacy, and safety. So in terms of data, it's throughout like how do you get high quality data and how do you even organize all of the data in the world? And it's becoming like the more data you feed, it's not a linear curve, but right now where we are, the more data you feed and the better data you feed, higher quality, the better outputs you will get. So how do you even source some of this data? Even in terms of like model evaluations, RLHF, it's all still actually at the end of the day pretty human dependent. So how do you, and there are companies like Scale AI that are coming in to help you with this, but then it still becomes a large operations challenge. And then how do you make sure you're getting higher quality data for training as well as for evaluations? Because ultimately that is what influences the quality of the model. Privacy is another one. With data, it comes privacy. How do you make sure that you are like there is privacy ensured throughout? Also, like which is both from data side, also actually on the inference side as well. How do you make sure that when the model is analyzing the user's question, you are only using the information that the user has allowed you to do? So having privacy implementations throughout, like we have a pretty large focus on that as well, to make sure that all the data we source, like for example, there are countries like EU, Brazil that don't allow you to use their data. So you have to make sure that all of those tools are in place. The other thing is around just safety, which is kind of going back to the misinformation aspect that you were mentioning. Like these models they can hallucinate and they can also just be misused to generate the wrong kind of output. And how do you make sure that the model is trained and not giving false information or generating unsafe output? Like there was this famous example of I think a deep fake of Taylor Swift that was generated and floated on the internet. I think those kind of things are very real problems with AI, especially on the generation side. So the models need to be trained to not do that. It is a very hard problem to solve. You also have to make. I think the companies are still figuring out how to actually solve those. But AI has its good. It also has a bunch of challenges that need to be solved. I think you're on mute, Sreshi.
Okay. Yeah, thanks, Meenal. I do agree that there needs to be frameworks in place to detect such misinformation, so that, not only like for like Taylor Swift, who is a very renowned individual, but also for, civilians, the ordinary people, like our information is also at stake. So I think it should be prevalent for everyone. So I'm also curious to hear from Aksa and so Professor around this topic. What's your thoughts?
Yeah, I can add to. So, Meenal, you covered a lot of great topics, including data and scale and safety and privacy. I think a couple other examples come to mind is when we are trying to apply AI, a generic purpose built AI to different contextual experiences, whether it's in different languages, multilingual context, in different cultures. AI often misses like what is the cultural nuance or what is like applying is English specific model trained on like an Arabic or a Hindi or Marathi language. And I think that is often where if that is not sort of captured early on, it sort of like continues to feed the model and the model just grows on that, leading to then eventually bad cases like bias. So multilingual context is also one of the challenging areas that is not, I don't think, fully solved. I think the other piece is around transparency and explainability. Traditionally, even for ML applications, let alone like Gen AI, like Gen AI is today, but like even ML applications have been termed as like black box, and we've often required human assistance to explain the insight or the numbers and have a story and logically flow into like why is a particular model predicting a particular response or a generative AI giving that specific result. And I don't think that is like a fully solved problem either, right? And some of the human in the loops and evaluations are like and benchmarks are trying to solve that, but explainability and transparency largely still remains an issue in addition to some of the scale and data challenges.
Yeah, so far I think human in the loop is very much like in demand right now for any AI applications. Yep. So I would also love to hear from the from Professor, like what do you think from academia standpoint about this topic?
Right. From the academic point of view, right, when we're doing research work, at the time, first important part is the data quality and whatever the data we are using, the availability of the data, and right now the social media data, the size or the scalability is the major challenge because the vast amount of data when we are processing in our say i5 related laptop or desktop, it is having say 8 GB RAM, it is quite very difficult for us to process this large amount of, rather than we can say big data. Second point is that data security is a really major challenge, and that and AI, all the AI model is not generating the accurate result also. Aside, AI models can be biased sometimes. They are producing some incorrect result as well as, and some whatever the data is present in our say, when we are doing say downloading data from their government open data initiatives, different government data as well as from Kaggle and other sites, some wrong information is also present in that particular section, and certain like different AI decision making process can be unclear in certain aspect, and the proper framework to identify the proper framework is another challenging task for us, and some these are the some means continuous monitoring and update is required. AI systems require ongoing maintenance, and to stay effective, we have to update the system, and update this updation or feedback process is very important.
Yeah, I mean, you brought up a very good point. First of all, bias and then the feedback mechanism. So I want to like shoot the next question to you as well as a follow-up. So how can companies or, the research institutions address the issue of algorithmic bias in content moderation systems? Because, we see in any social media platform, right? Like there is a lot of content filtering happening, whether it is based on the user preferences, whether it is based on any other aspects. And so would love to hear from you how, and all of us in the panel, that how can this be addressed? How can the issue of bias be addressed when we are, doing content moderation, content filtering, and they need to be fair and accurate, right? So what are your thoughts on that?
From the academic point of view, I can say that this algorithmic bias in content moderation, it can be handled through uh, diverse training data. These are the ensure the data set are representative of different perspective and culture as well as languages. Regular auditing and testing the data set to identify the address bias through a regular audit and test is required, and human oversights and like implement human review process to detect the correct AI errors is another important point. And continuous monitoring and updates for regularly adapt the changing which is done. And fairness, some fairness metrics is required, like establish a fairness metrics to measure the bias and fairness in content moderation. So, and as I said, that feedback mechanism that allow users to provide feedback on content moderation decisions, and the collaboration and knowledge sharing is another part. We can share the knowledge and best practices with other companies and researchers that will help. These are few points from my academic perspective.
Thank you, sir. I would also like to go to Vipul, because Vipul, you mentioned about the dark side of using some of the AI technologies. So how do you think it will manifest when we try to, do content moderation or try to reduce the bias?
I think when we do content like moderation, it will definitely help the dark side. What I told, it'll definitely support it. But I think it all depends, right? Like model are open source today, so every single model at least are open source. So anyone can just build upon the model and can run the model in, let's say, his or her hardware, and deploy it and just do whatever they want to do. So moderation, of course, at an organization level is a easier problem. I mean, of course, it's a hard problem. Easy when you look at the global scale. How do you think about this moderation globally? Where I think that's a very, very tough problem. Maybe like one country might support policing it, and other country might not. But internet is global; it's not local. So yeah, I think for that, I think in my mind, I think a lot of companies, government, and everyone has to come together. And I know like a lot of effort is being taken place. Like I've been hearing about everyone, all the leaders coming out and talking about this. I think it's just about an action plan of how do we start building while it's still too early, rather than once AI is like fully mature. Of course, maturity might take a couple of years, but once we are in decent stage, I think it'll be a very, very hard problem to tackle. Same with privacy and GDPR, right? Like we are still trying to, we have solved it to an extent, but we still face so many challenges. But think 10 years down or 15 years when internet boom started, and if we would have thought about modeling this better, a lot of this challenges would have been easier. So that's what I think. But yeah, moderation will definitely help, I think. 100% agree with that.
Cool. Yeah. I think having that context, having that early detection methods, I think that would help definitely. I'm also curious to know from Aksa and Meenal, what are your thoughts regarding like building products, and so that we do not have, not have, I think inherently we could have some bias. It depends on the data sets to be used. But I would love to hear your thoughts as well.
Yeah, I can kick us off. So typically in product development process, like usually what has been the case in case of deterministic products, where there's like a usual set of like happy path and you have like a defined set of outcomes. There's a very like typical stage process. You have an alpha release, you have a beta release, and then you follow like general availability. And the delta between going from an alpha or early access to a general availability is not that large. You won't fundamentally change a lot of your capabilities. You'd be incorporating your feedback, user feedback, making it better. This sort of model, product release and development model, has fundamentally shifted with AI products, because with AI, you have your early model and outputs like very quick and dirty. Like you have a lot of models of open source and proprietary just out of the box today. And so for your use cases, let's say like a chat application or a predictive analysis, forecasting, you can quickly get to that alpha, but the real value and iteration like lies in that subsequent refinement. And so this is where like a lot of product development processes are changing or like evolving to better suit or adapt to AI, because once you are able to get more and more production data into your models to refine them, train them, help them relearn, is where you will get your actual like quality out. Because no matter how much you try it on your test data, ultimately that's not fully representative of the like production quality characteristics. So I will say that is one of the things that is changing in like product development, where the time to go to alpha is like super quick, unlike previously, but the duration from going from alpha to a fully baked like really ready product is much longer, and there is a lot more iteration needed there.
I'm curious, like what are the challenges there? Is it the trust factor, or is it really like the accuracy factor?
I think it's a mix of both, because when you have this initial release, your model is just built off of like test data. It hasn't covered a lot of the use cases there. There isn't enough coverage. You also haven't seen what the bad actors are trying to do and how they are trying to game the system. But once you get into production, you are discovering a lot of these cases, which traditionally with deterministic like product management has not always been the case. So it's a mix of both.
Yeah, definitely. Meenal, any thoughts on that one?
Yeah, so I think in terms of just safety, maybe I would just categorize this as safety. And what the way we think about this is we actually measure our models on metrics, which include not just how accurate it is or how helpful it is, but also kind of how harmless it is. So there are safety metrics that we have in place. In addition, there is a lot of red teaming that goes into these models to make sure that we are really checking these models and making sure that any bad outputs that might be generated are covered while building them. Then there is, I think, having metrics is number one. Number two is also just running a policy and privacy check to make sure that you are not violating any of those. There are pretty strict measures for that as well. So I think during development, those are some of the ways, which is the one, just having metrics and measurement in place, like full red teaming to get that there. And number two is like just making sure that the privacy and policy checks are also done, so that like if a user does not want to be opted, like that is they are not opted into something. So I think those are some of the ways to actually mitigate and moderate and make sure you're not generating violating content. That said, like Aksa said, there is only so much you can do before production, but you can do a lot with red teaming. That said, there is like once you go to the market and you have the world trying to use the model, you start learning how people are using it. And at that time, a slow deployment or a slow rollout helps, because then you can just open it up to a fewer set of people and make sure that you're constantly monitoring the feedback and seeing how it's working.
Cool. Yep. So I'll go over to a next topic, which is like I want each of the panelists to just let us know one real world application where AI and social media converges. One could be like emergency management. Like we know if there's an emergency, the social media like Twitter or Facebook, we get a lot of notifications and awareness of these kind of use cases. But I'm also curious, like if you have any other applications in mind which are prevalent today, and we'll go over one by one. And then later, after this, talking about the existing one, we'll cast some light on some future ways how it can be approached between AI and social media. So, Meenal, if you want to start, yep.
So I think one of the ways where it's really helping people, I would say it's kind of somewhere in between today and what's coming, is I think tutoring and learning support to me is pretty interesting, and how that's evolving and how AI has changed it. Especially with conversational agents, you can essentially just go and ask AI to help you teach a topic, and it has made education universally accessible. So to me, I think that AI has the power to fundamentally just change how education works today. And that is very interesting, because I think like having kids who are trying to just learn a lesson or just trying to get help on their homework, instead of just going and trying to find a tutor, you are now able to have AI as your tutor. It also has its downsides, but I think that use case has been very interesting and very like I think I saw some data that about 50% of students at this point use AI to actually help them with homework. I think that I actually think that use case will evolve more and more, where AI is not just to help you learn, it can also help you find mistakes. It can almost be your teacher or your tutor at home, and sometimes an assistant to the parent who are trying to help the kids as well. So that use case has been something that has been quite interesting for me to follow.
I have a follow-up question on that. Like, for example, like we know like the social media is a platform where people come together, like connect, build connections and do that. So, but when we talk about using AI in social media, we are talking about a person's expertise of using a tool, right? Would it cause a lot of division or would it still make those connections stronger?
You mean a person's ability to use AI as a tool? I think it can, I mean, a very simplistic application of that would be, I think AI, one of the things about AI is it should not just be about giving complicated tools, but also about simplifying it such that every user can use it. And that's actually the power of like AI that's evolving now, which is anybody, like I don't need to be a sophisticated user to be able to use it. So for example, like all of the now you can go and real time generate emojis and GIFs and send them on social media. It's just a better and more fun way to interact. There is a new feature that was launched which allows me to generate characters of myself in another form. Like I think Meta just recently announced that, which is Imagine Me. That's a very fun way to engage. But I think the key part of social media and AI, and if it really has to change how it works, is to not just build these tools in the back end, but also make sure that you're providing user experiences that make it easy and simple and fun to engage with those. By the way, Imagine Me is another fun one that I'm really excited about.
I'll try that out. I haven't tried that yet. So, yeah, I will love to go to Vipul. What are your thoughts on this one?
So I think one thing I find interesting, and I've been seeing a lot of news around it, is how AI is helping doctors to spot, make diagnosis very easy and efficient, more efficient. So just like a spot check, basically. So I think that area can do wonders because our medical staff are very busy, and sure, we have to go to the testing center, but that is more of an infrastructure we need to set up. But at least if that first level of detection is taken care for simple to complicate disease, I think that can do wonders in our lives. At least in a country where not lot of availability of doctors and medical professionals are there, and that way doctors or anyone can even prioritize how to treat them basically, or whom to treat, like when in case of like a lot of people flowing in. Yeah. And even maybe like AI can help like first level of treatment to a patient, very generic. So I think that can definitely, I see that doing wonders. Sure, there are downsides of it as well, like as every good problem there is always a downside, but I think I do a very good upside here. But yeah, I think anything, a mistake can be, like AI can do mistakes as well. So that's why I said like it's like a companion rather than the like replacing a doctor or replacing a radiologist or whoever, right? So I think yeah, I see like a very big theme playing, and I think a lot of startups are already investing in this area. A lot of hospitals or big organizations have already started implementing it. So yeah, I'm very looking forward to that piece.
Do you think like social media platforms would be a big part in this journey, where people would develop more trust in automated medications?
Uh, Not again, I don't think this field is related to social media because of the privacy and other concerns. I think sure there would be applications, and there would be like websites and personalized approaches here, but I don't think it's like a very social media kind of a thing. But yeah, that's what I think. But I mean, I'm just talking about general AI, how like what I. But yeah, when you talk about like if you're talking about social media plus AI, yeah, I think learning is one of it. What Meenal has already spoken.
Yep. So over to you, Aksa. What do you think?
Yeah, so I am in ads measurement, and so I've been thinking a lot about this space, especially social media is one of the ways where brands reach their target audiences, and a lot of large brands spend a large marketing budget on social media, and advertising to reach their target, not just audiences, but drive their marketing goals and eventual business outcomes. And so where I see AI and social media is converging, typically brands have relied on these very long processes or like campaign, like we measure the campaign performances, right? Like after a campaign concludes, you typically go into like a measurement phase, which is prolonged for like weeks to several months. And I think with AI, that is changing, and also like ripe for disruption here again. And some of the concrete examples here are in terms of brand health monitoring. And if you look at that traditional like ad funnel, like you have on the top, you have brand metrics, so like you're trying to reach more users, create that awareness. But how do you really understand the impact of that brand spend is still through that lower funnel metric of unless a user converts or the sale has been made. And so you have to tie those top level funnel metrics to the lower, like bottom level, lower funnel conversion metrics. And that is one area where AI and predictive modeling has been able to like shorten much of these long measurement cycles into like almost near real time, if not real time measurement. Some examples include when an advertiser is running this campaign, they are able to almost instantly optimize whether they are reaching their target audiences. There's Shopify has this called like audiences overview, or almost like lookalike audiences, and so they're able to quickly reach the right people, the right product, and show them the right product in the user's context. So I think brand health and brand monitoring and reaching the right audiences in the right moments is definitely one area where AI and social media is converging. The other example I include is also as it touches to like the creator economy or influencers. Today, a lot of brands have partnerships with influencers, but we don't necessarily know which influencers drive what kind of traffic or what kind of brand outcomes. And so based on the audiences for these influencers, and by influencers I mean like either small and medium like celebrities who are trying to who have a large follower and like large audiences that follow them, but and at the same time they are partnered with large brands who are trying to reach these audiences. And so one example there is this instant or like influencer recommendation to the brands, and this is the audience you are looking for. This influencer has a following of exactly those kind of audiences, and so a partnership between the two and is ideal. And so helping make some of connections or based on AI powered recommendations between the brand.
Yeah, I think you brought up a really good point about marketing and branding. I think Aksa froze. Is it for all of you or is it just for me? Okay, we can move on to Professor. Professor, like what do you think about assessing consumer behavior on social media?
Okay, so like consumer behavior on social media means it is just like in regular way. Hello.
Yeah, I can hear you.
Okay. So different factors are there, like different I'm not getting your point. Just can you repeat that question?
Yeah, sure. So we know that in different social media platforms, we have different organizations like targeting different strategies, like marketing for marketing purpose, for branding purpose, like Meenal was mentioning, Aksa was mentioning. So I'm curious, like from a research standpoint, like what do you see are the existing tools and technologies that are used to assess consumer behavior on social media platforms, if you're aware of any.
Okay.
Like, for example, like, the content filtering that we mentioned about assessing consumer behavior, like how can we like use the user preferences or something? How the brands are able to target different consumers?
I don't have certain idea in that point. Okay.
Okay. No worries. So are you aware of any applications, like existing applications on social media platforms that are using AI?
Obviously, lots of, like, for example, we are using Google Translator to translate. Google Translator really helps us to translate our language from and apart from that, the healthcare sector and different traveling part. When we visit any place, you just book the hotel, restaurant, and all these things. Like so, apart from that, many like in banking sector. Maybe myself, I have not visited any bank for the past 1 or 2 years, because everything we have done through their online applications. Like, for example, when I watch Netflix also uses some conventional AI that suggests some personal content based on our viewing history. And in education sector, like my son is using the Duolingo app for learning the French and other languages. And myself, I'm also using Coursera, different type of platform that offer personalized learning experience and adapting the users to increase his ability. And like other different virtual assistant, like for Apple, there Siri is there. For Amazon, there is Alexa. Microsoft, there is Cortana. The different voice interaction assistant is we are regularly using in our day-to-day life. Apart from that, like smart home systems is already there. Food ordering, we're using different AI-enabled chatbots. And these are some examples. Okay.
Yeah. And what do you see in the pace at which the AI is advancing? What do you see in the next 5 or 10 years? Would say like just one line or two lines from each of the panelists. Like what's your dream kind of connecting product, like where you have the convergence of AI and social media, and where do you want this future to be in the next 5 or 10 years? If everyone can you just chime in.
I'll quickly go. My internet is a little unstable, so I'm going to keep the video off. I think agentic workflows are on the rise, and I think that's not going to die down. That is a trend that will just continue. Examples include agents from all corners, from we've discussed examples here, like medicine through learning and personalized tutor to the one that I am most excited about is data analytics in enterprise space. Today, everyone needs data, and we are reliant on the data analyst who only has so much bandwidth. And so an agent to help augment those workflows is I think, very exciting.
Absolutely. Meenal, any thoughts?
No, I definitely agree with that. I think like in 5 to 10 years, I would imagine AI can take over all of the tasks that don't necessarily require a human to do them and be their agents, and all of us will have assistants or agents who can actually go and perform these actions for us, and humans can then take a more creative layer on top and add a more subjective layer on top. And that's something that I hope the future has for all of us. I think in terms of just social media as well, I would think that AI can actually help improve and probably make better connections as well on social media. Improve the connectivity that currently exists by, for example, right now, it's a very one where we have to go and we have to engage and then find the right forums. What if AI can act as our agent on social media as well and help us give proactive notifications or nudges when, let's say, there is a birthday of a friend? It's able to just know and be aware of that and act as your assistant to go and wish somebody a happy birthday, which can just be a very, very simple but meaningful application for all of us.
Exactly. Vipul?
For me, one of the biggest theme I'm very interested is how AI can change the personal finance journey. So personal finance was very sacred to a few bankers, and it's changing now, but it's still like even today, like we have see a lot of traditional investment firms and bankers and hedge funds and running like very secretive stuff, which is and makes it very complicated. You find information online through friends, through like channels like stock tweets, but it's very close circle, I think, still. So how that open access of investing and learning and knowledge transfer, I think, yeah, AI can make wonders in that, I think. And it again, it's up to you. You can control the narrative of your what you want to do and tell AI that this is what I want to do. But yeah, if that can be automated, I think it'll help so many people not to pay unwanted fees and money, I think so.
Yeah, we have a closing comment. Professor, do you want to add something as well?
Yes, from my point of view, like AI-driven system that detects and removes the harmful or toxic contents from the social media is really important. And other part is just like IBM, they are doing one of the great research in blue brain technologies. Okay, if this type of things is possible, then we can store their overall knowledge. Like we can access the knowledge of the Einstein. We can preserve the knowledge who passed away. This blue brain technology, if it is feasible, then it will create a great revolution in the field of research.
Great, great, great. Thank you, everyone. We are at time. We are almost over time, but thank you so much for joining this panel discussion. It was really an enriching experience for me as well as everyone who was in the panel and the audience as well. So the idea is like we need to strike a balance between all the positive impacts that we have discussed and also like the ethical risks that AI also brings forward. So we are looking ahead for a brighter future. That's all we can say. And let's continue the conference. Thank you, everyone, for joining. Bye.
Thank you.
All right, thank you so much for the great discussion, everybody. I would now like to turn our focus to the next talk from Mr. Raghavan Muthuregunathan about accelerating code contribution with Code Case Buddy's intelligent semantic search system. Mr. Raghavan Muthuregunathan is a senior engineering manager leading the LinkedIn Search AI team. Earlier, he worked at Microsoft Bing. He is also a volunteer and a contributor to open source initiatives by Linux Foundation's LF AI plus data, specifically to GenAIComs.org and Apache Solar. He's also an active hackathon participant on LabLab AI and has won multiple hackathons on the platform. So I would like to hand it over to Mr. Raghavan for the discussion around this topic.
Good morning, everyone. Thank you very much for the opportunity, and thanks to Meenakshi for helping me getting this opportunity to present. Let me share my screen. Can everyone see my screen?
I'm not able to hear. Is that just me?
Okay.
We can hear fine. Maybe your volume is a little bit lower side, but yeah, we can hear.
Can you folks hear me now if I speak up a little? Okay. Please call out if you're not able to hear my voice.
Yeah. It's on my side, I think. Yeah, you're good. Thanks.
So thank you for having me. The topic that I'm going to talk about is semantic code search, which is do-it-yourself semantic code search. Thank you for the nice introduction. I'll give a very quick about me. I'm a senior engineering manager at Search AI, LinkedIn. I'm also a volunteer for GenAI Commons, which is part of the Linux Foundation. And I'm also an active hackathon participant on Lab.ai. Views are my own. They are not representing my employer. Now, the problem that I want to talk about today, which is that let's say you are a new developer who is trying to contribute to a new code base, or let's say you are a manager who has a set of new developers who are trying to contribute to a new code base for a beginner task. Just knowing which file to change, where to make the change can be time consuming. It's not a straightforward task. This is not about code completion. If you go look at a lot of applications on the internet for coding, it would be, especially in the large language model era, they would be about code completion. I am not talking about code completion, but rather I am talking about you have a specific task in mind, but you don't know where to start. You don't know which file to change. And we have all been there. Like this happens during our early stages of the career, or whenever you go to a new team and you are a developer. So I developed a hack to solve that particular problem, and this was originally submitted for Open Interpreter Hackathon, and then recently I made a modified version of it for Cholesterol Hackathon. So at the end of this session, I would want an engineer to feel that yes, I can play with this new code base or new GitHub repository, and without having to bother a senior engineer, and be more productive. So before I start, I would like to ask a question, and feel free to post in the Zoom chat. What do you do, or say the developers you know do, when they do not know where to begin on a new repository or a new code base? What tools do they use? I would love for this to be a little more interactive. So put yourself in the developer shoes if you're not a developer, or if you have developers reporting to you, or if you are a developer. What tools do you use to understand a new code base? Existing documentation, great. Running some examples and documentation. So I actually asked ChatGPT this question, and thanks to it and Sumit. Topmost one is read documentation. Second one is code walkthrough. Start small and then look at the version control history. Code analysis tools, use IDE to understand the code base, etc., etc. But number one is, say, as you guys predicted, read documentation. How often do you think documentation exists in practically? It does not most of the times, because thanks, Amit. Git local documentation code analyzer. So most of the times there are times where the documentation is not updated. So park that for a second, and then in the large language model era with the advent of AI, what is the most popular RAG application that you see on the internet? Like if you start with LangChain or Llama Index, with the retrieval augmented generation example, what is the most common RAG application you see on the internet? Can anyone, in your opinion, what is the most common application that you see on the internet? Any? Feel free to type in the Zoom chat. Maybe, but I don't think that's the automatic code documentation, maybe. But there is something that is even more popular, or at least in my opinion. The most popular 101 retrieval augmented generation application with LangChain or Llama Index that you see is usually talk to your PDF. Like you have a set of documents and then talk to your PDF. Do you guys agree with that, or it might be just my sampling bias? So the most typical RAG application that you see out there on the internet is talk to your PDF, which is nothing but you take a PDF, convert it into a series of chunks, break them apart into chunks, and then you use an embedding to store that in a vector store. And then when someone asks a question, you query that vector store, get the chunks, use a large language model to answer. Are you guys familiar with this pattern? This is the most typical 101 starter example that you would see for LangChain or Llama Index, etc., etc. So what I did is I just married these two ideas, which is the problem of solving for your code base. Instead of making talk to your PDF, why don't we do it talk to your code base or talk to your code? So you have a local repository, which is a series of files. Each file is a class file, if it's Java or C++ or Python. Then why don't we generate an embedding for each file, store them in a vector store, and when there is a question, um, retrieve the top K files that are relevant to that question using cosine similarity, or do the standard nearest neighbor search and get the top K files, and then use a large language model to get an answer. So what I'm trying to say, how I got the inspiration. The inspiration is you have a problem of trying to find asking questions to your code base because you are a new developer, and then the most common application out there on the internet for typical retrieval augmented generation is talk to your PDF. So instead of just talk to your PDF, I just changed it to why don't you talk to your code? So which is which is instead of converting PDF into chunks and then generating an embedding for them, storing in a vector store, generating chunks and using a large language model. Now do this on code for for every single file, store it in a vector store, and then when there is a question, find the most relevant files and then use a large language model to come up with an answer for it. So, and I want to show you that it is possible to build this fully with open source or partially with open source. So if you see in the previous diagram, see you have an embedding and you have a large language model and you need a vector store. The three things that you need are an embedding, a vector store, and a large language model. So the embedding can come from something like SentenceBird or Code T5. The open source or closed source version of that is from OpenAI's ADA. You don't have to pay. Open source is free. You can use large language models like GPT series or Claude, but you have to pay for it. But you can also use Llama, Mistral, E, the open source versions of it. Depending on the license, you can choose to locally deploy or you can deploy in on-prem. And there are many closed source versions for vector stores, and there are also open source versions of vector stores. In this particular example, I used I'm going to show a code implementation of the same. I used SentenceBird for embedding. I used Anoi for vector store, and I used GPT series, and I also used Llama. Llama and E. So let me show a quick example of what I'm talking about. So let's say there is this repository called local GPT. Local GPT is a popular repository on GitHub with close to 20,000 stars. And I want to simply ask this question of which file should I change to add support to a new Falcon 180B model. And I built a simple application using Llama Index, and this is the output it gave. This is basically a simple 101 application in Llama Index. And I just changed that 101 application to talk to a code instead of talking to PDF. By the way, if you're not following, if you have a question, just feel free to raise a hand or put it in Zoom chat. I will stop and immediately answer your question. I simply asked it a question, which files should I change to add support for Falcon 180B model? And in return, it said, hey, because it had created this index, it said to add support for Falcon 180B model, you should change so-and-so file. And these are the constants.py and set the model ID to appropriate identifier, etc. etc. Yeah, I also have a screenshot to show that I am not lying. What can be better? What can be better with this solution is I'm looking for a more detailed answer. I'm looking for list all the files that needed change as much as possible. Give instructions of where to change within each file. So in the interest of that, I developed So build a vector store using sentence PERT embedding, using look at traverse through every single file in the GitHub repository, use sentence PERT embedding, and then use vector store and convert them into a vector, and then build an annoy index out of it. And then at the time of user querying, you can query the vector store, get the top K files that are relevant for it, and then you can use an LLM prompt and generate instructions out of it. The standard retrieval augmented generation paradigm out there in the internet. So I did this for close to 5 different repositories like LangChain, Llama Index, Open Interpreter, Local GPT, Solar. In the interest of showing a demo, I'm going to directly go to the demo of it, which is say, see if I have it run. It running service. So let's say I want to ask a question about the popular GitHub repository LangChain. I have created an index for it. And then the question that I want to ask is, how do I make changes to the summarization prompt? Okay, let's see, that's the question that I want to ask. And then the tool that I built was able to say, hey, refine prompts, entity summarization prompt, map reduce prompt, and stuff prompt are the 4 files that you may have to change. And it's still running for giving each summary for each file, which it should take a few seconds. And in the meanwhile, while it's doing that, I can go back to the presentation and say that when I had developed this as a terminal application instead of a GUI application, and it told me when I asked the same question of where should I make changes for the new summarization prompt, it retrieved these 4 files, and then it also told me that in order to make the changes, you have to make changes within the prompt template of these files. So just assume that you are new to LangChain and you are asking this question. Just getting these files and are giving you a starting direction in itself would be very productive, especially for a beginner, right? So yeah, so for example, in this case, it said, hey, in the refine prompts, the purpose of this file is, it is specifically known for summarize. It's a summarizing module. And it's the main purpose is to define the templates for summarizing prompts, which are used to guide the system and your user in refining summaries of text. And then it also says the second file is entity summarization. The purpose of this file is so and so. By the way, I am not a LangChain expert. I'm not a I shouldn't say I do use LangChain a lot, but I'm not an expert of its repository structure. But the fact that it's saying that this is the purpose of the file, these are the necessary changes that you need to do, saves me enough time that I do not have to manually go into each of these file and change it. I'm sorry, read it and understand it. Assume that whether especially when the documentation is not there, or the documentation is continuously changing. So this definitely improves my productivity. Similarly, I did the same for Llama Index. So let's say I go to a different instance and say for Llama Index, I'm going to ask, how do I add support to Apache Solar, just like supporting Elastic search index in search index. Let's say I want to see the 4 files and then say I'm going to use Llama Index. So it does take some time. It says that, hey, there is it's referring me to the Elasticsearch files, saying that you may have to look into these Elasticsearch files. There is an init.py and there's a reader, and then there is base.py. So it takes time because of the external calls. And if I go back, what answer did I get for this? So yeah, similar to Elastic. This was when I had it as a command line application. It said similar to Elastic integration, which file should I change in order to support an Apache Solr and Llama Index? And you can clearly see that it said, it suggested both text files and implementation files. So it was able to say that these are the files that you need to change. And it also said in the readers, you have to update the schema. In the init file, you have to import various readers. So let me go back to see if this is done. Oh, sorry. Yeah, again, the purpose of, sorry, not this one. The purpose of this file, purpose of the init.py, and then the purpose of Elasticsearch. So it was clear, it's clearly able to say that in this case, you first need to create a new directory for Solr, and then under Llama index readers, and then you need to create a new file called base.py, and then this is how you read the Solr reader, just like you have for Elastic. So Solr and Elastic are competing search engines, or I should not say competing, but two alternatives for search engines out there in the open source. And if I have to make support for Llama Index, if I have to create support for Llama Index for both of those search engines, it's telling me at least these are the files that you need to change, and this is how you change it. And for every single file with sample code snippets, which is again a huge productivity improvement as an engineer for me. So I can go on and on with several examples. Similarly, I used this for local GPT. I asked where should I add Falcon ATB. I got a good result. Now, I would like to pause and say that, is there a way for us to use, for us to avoid GPT calls here? For example, say if I have enough money, yes, I can train my own large language model, or I can deploy a large language model in on-prem. But for a developer like me who doesn't have enough money, is there an alternate for that? Oh, by the way, before I get into that, any questions? Any questions so far on the application itself, or how I have built it?
Hi, this is Amit speaking. So my question to you is, for this kind of application, I mean, if the code is available publicly, that is fine. But if it is, the code is, it's a secure company architecture where, healthcare or sensitive data is available, or a banking data, you cannot deploy such models without appropriate security measures. How do you use this application in such environment, or maybe
That's
a
great.
defensive? Yeah.
That's great. That's where I'm going to go next. So who asked this question one more time?
This is Amit.
Very, very good question. So just for my own understanding and ensuring that others understand, Amit's question is, hey, for GitHub repository, which is closed and secured, it's not okay to use the GPT style LLMs because you are going to take the piece of code and you are going to send to OpenAI, which is sensitive, because you may carry sensitive information in that. How would you avoid that, or is there a solution for that? Is that a good way of summarizing your question, Amit?
Precisely, yes.
Yes. So this is where there is. I'm going to kill this. Then. There is this tech. I think it would be easier for me to show on terminal rather than going back to slides. So Olama is an open source tool that lets you run and download large language models that your local laptop can hold. For example, you can clearly see I have downloaded Codestrol, DeepSeek Coder, Llama 3, Mixtral E, and the space that they are occupying on my machine is like few gigabytes. While their accuracy or quality may not be as good as GPT-4o, or say as good as, or their inference time might be much slower than in GPT-4o, they provide this privacy aspect. For example, if I am say Olama run E, I am going to basically run Olama within my laptop. Not so I can actually, who is the president of ICADS of US, or let me ask because that keeps in yeah, so I have a live large language model running on my laptop thanks to Olama. And if you're building this application through SentenceBird, which is an open source library that is downloadable onto your laptop, and a large language model, sure, it may not be of the same quality as GPT-4o, okay? But privacy comes with a cost. So if you can get a large language model to be deployable on your, especially for an application like this, and it's okay for you to wait because the token inference times for these are going to be slow compared to that of GPT-4o, and the quality definitely is going to be slightly lesser than that of GPT-4o. But the upside that you get, the advantage that you get is using something that is private on your laptop or on your desktop. So let's say I also built the same application using Olama, where instead of using GPT-4o, I used Olama. And where should I make changes to? Forgot the question. Same. Let's say I want just 4 files in a language chain. It will get these files easily, but this part is going to take much more time because a large language model is running currently on my machine as I am delivering this on Zoom, and which means the CPU time is going to be very slow. Because I am running multiple applications. I am talking to you guys over Zoom, and I'm also running a large language model in the same machine. So because of which both the inference time and also the quality of this is going to be slightly lesser. Inference times is going to be faster. But this is the answer to your question. Amit, I was going to cover this, but your question was like right there. So answering your question was in help me cover the next set of the slides that I wanted to show. Does this answer your question?
I have many other questions because I also work on enterprise search, and if anybody has other question, I can just park it and wait. If nobody has, then I can ask now. I have like multiple questions for it.
Yeah, so see, as we spoke, I got the results. See, the results for this are slightly different compared to what I had for GPT-4o, but still, nevertheless, it's giving me step-by-step instructions necessary. I need to go check which model is it using. Probably it's using, it's using Codastral. So it's using Codastral locally, and with that, it's able to generate these responses. And this is all happening right within my laptop. If I can pull the plug of the internet, and this still work.
Does anybody has a question, or if I can ask more?
Yeah, maybe I'll just finish this one slide.
Okay, I'll let you finish. Yeah.
Thanks to Amit's question, he kind of covered the section that I wanted to cover after. So the crux of the point is when you don't want to send everything to GPT-4 or GPT-4 or any closed source proprietary large language model. The alternate is you can use something like Olama, have a large language model deployed onto your laptop, and then one file at a time you can send it, and then you can get the response. So there are pros and cons to this. Pros is that it's open source model. It's not expensive, but it's locally available, and privacy. Privacy, you cannot put a price on privacy. The con is that because we are sending one file at a time, some combined context is missing, and obviously GPT-4 is way superior in terms of quality compared to these models with lesser number of parameters, and there is increased hallucination. So what is an advantage of a system like this? An advantage of system like this is that it accelerates onboarding of new engineers in the team. And given that there is some very specific guidance, there is reduced errors. And a supportive tool like this will almost always increase the engagement of the engineers in the team. And even for an experienced engineer in the team, sometimes they tend to forget where the code is or which part of the file needs to be changed. This tool can be a means to discover the lesser known parts of the code base. And this can also aid in documentation. So future work, given that we are generating embedding per file, which is instead of chunking, we are basically chunking at file level. We could actually chunk at the method level, which would actually generate more granular information. And then we could actually use knowledge graph instead of vector search, and we could also fine tune the local LM, the local LM cholesterol that I'm using here. List, yeah, I'm using cholesterol, which is 12 GB size. Could be fine-tuned for my specific task. With that, I'll open up for questions.
Okay, thank you, Raghavan, for the insightful talk. I think it's certainly useful for developers to use this and improve their productivity. We don't have any questions in the YouTube chat, nor we have questions here in the chat. So I think Amit, you can go ahead with your questions.
Okay, thank you. So, Raghavan, thank you for your presentation. I just want to ask questions about the algorithm. So you have chosen cosine similarity, but there are other options as well, like BM25 or Zaro-Winkler. I used Zaro-Winkler long back. That's one. Why did you choose cosine similarity? I mean, if it is a question of scalability, how will this fare? Number one. Number two is the assisting the users to search better. What can be done? So, for example, can you add autocomplete? Can that help? So that people search better. People may not know the entire code and they might have wrong queries sent. The third is about the metrics, how you are measuring whether people are searching correctly and they are landing to the right search. So the intent, are people able to successfully query things and get the result? And any reporting structure that can be shown that, using this application, X number of users have searched and they were able to resolve their problem.
Okay, so question. I took notes as you spoke. These are the three questions that I have in mind that I think you asked. So, how will this scale? I did not intend to make this a software and that is deployable on cloud for other people to use. I intended to make this something that is self-sufficient, that is deployable on laptop, and you can pull the plug on internet and it would still work. So my focus was on making a new engineer in the team or a new onboarding person in the team to be more productive. So that was the focus. And with that focus, actually, I think I'm answering the third question first. So with that focus, it's up to the engineer or it's up to the one who is using this tool, because the success of this tool is to become productive as opposed to if I could do the code walkthrough, the engineer can tweak the tool as they see fit to their needs. So the goal was to make the engineer productive to show that they can build tools like this to make themselves productive, as opposed to saying that, hey, I have developed the state of the art search engine for code search. So my goal was never to say that I am building state of the art search engine for any code search, but rather to say that anyone who is reasonably good at coding can just use these two scripts. One is building the index, and like the second script is to show the to do the call to a vector search, and then or say GPT or local llama to say that, sorry, local olama to say that, hey, I could build a tool like this and be productive on day 0 of my joining a new team. That was the goal. So that's why I did not measure against how well this is doing, because it's also very difficult to do that across large number of code bases. And then I'll go to the second question, which is why not autocomplete on other features? I built this for a hackathon, so I could do only for what I could do in 24 hours. I sure we could extend this to have autocomplete on other features, but I just didn't get the time. That's all. And then going to the first question, which is actually technical, which is cosine similarity versus BM25 versus other ranking metrics. Because I was using a vector search and I wanted to use off-the-shelf models, I went with cosine similarity. Again, this is not this attempt is not to move the state of the art in search ranking or search quality, but an attempt to say that such search engines or such tools can be built um, at very limited effort. All it took for me to build this just one day. In one day, I was able to build like this, and and building an index for something like Llama index, which has like more than 2,000, 3,000 files, just took half an hour. So building an index for a large repository on your local box, demonstrating that you can use a local large language model instead of GPT-4 was the intent, as opposed to solving the problem of search quality. Does that make sense?
Okay.
Yeah, I'm trying to say the intent was to make people productive rather than solving for the search quality problem, because that would be much more
Time consuming.
Yeah.
Okay. Got it. Thank you. This is fantastic. Thank you, Raghavan. Great job.
I had a question, Raghavan. Do you see any problems with different languages and the model output changing in a way that you wouldn't expect?
Very, very good question. Again, this is anecdotal. I don't have any objective data point to share. Most large language models do very well for Python and do relatively okay for Java. But for other languages like C or C++, I have seen a lot of, I have seen lots of errors, but that is very anecdotal. Python, Java, Python and Java. So to answer your question, I'm between language models, there is definitely a difference in my observation, and Python and Java seems to have the blessing of large language models, while say something like C or C++ or even some other languages, I have seen errors, but they continue to evolve.
So I might consider this as a follow-up. So let's say if I have a code base or which is not as popular as Python, and I would want to use or have these tools, how would I approach it? Like in terms of data and um,
I would say,
and what challenges?
I would say this tool will still work because code is still mostly English in nature. So so let me put it this way: what would work is, say, have I killed it or is it still on? So irrespective of the language, this part, let me go back to the local URL. Irrespective of which language, the part where should I make changes? That's my favorite query. The initial part of finding the right files should more or less work. The part where there would be substantial difference is the instruction that you're generating for each file. What should I do in refine prompts? What should I do in this file? What should I do in this file? That's the place where it may have challenges. So the tool would still work in getting the right files, but beyond that, where you're generating a text of instructions of what needs to be done, that's where I think there will be challenges. Oh, this, I think if you just search Codastral code base buddy on the internet, you should get the link to my presentation. This is based on that work. Whatever that I'm presenting today is based on whatever that I presented here. So just paste it as is. Yeah, to answer your question, Dweet, I'm not sure if I'm pronouncing your name correctly. Please correct me if I'm incorrectly pronouncing. Half of your problem should not exist because that retrieval by embedding should work, but it's the second part where you are generating instructions further for summary of each file. That's where there might be challenges.
Thank you.
Okay, I think that concludes our Q&A. Thank you, Mr. Raghavan, for this insightful discussion and well demonstrated demo. I think I will now turn it to Dwit for talk about Feed Forward magazine from Santa Clara Valley chapter. Over to you, Dwit. You're on mute, Dwit, if you're talking.
Yes. Just wanted to confirm, can you guys see my screen?
Yes, we can see it.
Yeah, that's fantastic. Okay. Hi, everyone. I'm the editor for the Feed Forward magazine, and I wanted to take this opportunity to shed light on what we are doing with the magazine and what kind of opportunities we have. Uh, Feed Forward magazine is the way we see it is as a platform for engineers and academic researchers in the Bay Area or worldwide to share their knowledge. And as you're aware, like Santa Clara Valley chapter is one of the biggest chapters in the Bay Area, and we have a lot of thriving big tech as well as a startup ecosystem, including great academic researchers. So we wanted to pull together, set up a platform where engineers could share their work and also, give back to the community and learn from it. So yeah, the overview of the presentation is I'm just trying to give you over guidelines on how to submit and what to expect, and more than happy to answer any questions you guys might have. So to get started, okay, so you can still see the slides, right? I'm on the second slide now. Oh, okay. So yeah, so Feed Forward magazine, I guess the incentive, as you can understand, is to share your knowledge and to a broader set of audience and be able to get the feedback and give back to the community. And as you can imagine, like this is a magazine that is run by the chapter, which means we publish it every quarter. So the articles that are published are open access, and we also don't charge any article processing charges or open access fee. No, and I also want to note that this is not the same as IEEE journal or a magazine. This is an IEEE Santa Clara Valley chapter magazine, and this is a question we get more often than not. Again, this is a chapter magazine that encourages people to share their technical contributions. And while all these all the articles that are submitted to these magazines are peer reviewed, um, uh, just to ensure the quality. So, a few things to keep in mind. While we do the best with peer review to ensure the quality of the articles, but the Feed Forward magazine doesn't attest to the originality. I think the onus of the originality falls back to the author. And I would like to take this opportunity to thank the editorial board, which is run completely by volunteers. I- just to mention a few names, Shreyasi is one of the co-editors. Dr. Vishnu is part of the editorial board. Meenakshi is also part of the editorial board. And Anbu is also a social media ambassador and a student volunteer here. And I will and this work would not have been possible without them. So I would like to take this opportunity to thank all of them for their great work and what they're doing for that tech community. And just in terms of high level guidelines, we have been receiving a lot of submissions, and we mentioned to the authors the typical time frame from publishing is usually 3 to 6 months. Again, we've been receiving more articles, so we are always trying to get them reviewed and publish them as soon as possible. But as I mentioned, we are a completely volunteer-run organization. So we would appreciate the patience and the collaboration that we get from the authors. So I just want to highlight for maybe the uninitiated and what quantifies it as a magazine versus journal. Like while we try to encourage topics that might not fit into the traditional research, while we also encourage pure research papers. We also trying to bridge the gap to include technical white papers. These could be your insights into your from your work experience, or given your experience working in the field and your expertise, you could share your best practices or recipes or how to guides. And we still see that there is a large wealth of knowledge that can be shared through these articles. So again, there could be columns to educate or inform the more uninitiated or non-experts in the field who want to learn more. So we expect these as a platform where people can come in, not as an expert, but as an curious engineer or researcher, and also learn from these articles. Um, so again, this is a few of the things how a magazine can address a wide variety of articles when compared to a scholarly journal. So this is what makes us more appealing to a larger set of audience as well as contributors to publish their work in the Feed Forward. I know a lot of you, the fact that you guys are taking time on a work day to attend this conference are definitely technically inclined, and I want to voice your opinions or learn more. So this is where we really encourage you to submit your articles to the magazine. Um, Again, we talk about, I mean, that we talk again, as I mentioned, the submissions can be a breadth of topics. So it could be sciences, it could be engineering, or it could be its applications. So we welcome all sorts of these applications, even opinion pieces. Um, And the idea again is to inform, inspire, and connect professionals in the field. And uh, typically, we expect around 1,500 to 3,000 words for each article. And again, currently we are publishing in English, and we also have these formatting guidelines for both LaTeX and Word doc. And we can all find this in the IEEE Computer Society Santa Clara Valley chapter website as well. Um, so yeah, I mean, one of the things as any magazine would require, as you know, we are a team of volunteers. So we really encourage authors to uh, submit their work in the required format, so that we can leverage that and make the publishing process much smoother. Again, this is essentially a call out for volunteers. We are always excited to grow our team. As you can see, we are receiving more and more articles. That's increasing the wait time. So we are always excited to have passionate individuals who would want to take this forward and contribute to the magazine. Uh, Primarily, we're looking for reviewers. These could be experts in their field who will be able to review these submissions and provide us feedbacks on how they can be improved. And they need to be able to identify the gaps in the technical content and provide useful feedback to the authors so that they can improve the overall readability as well as the technical content of the submissions. As part of the editorial team, we're also looking for people who want to review as well as edit and also be part of the board, being able to understand the latest technology trends, pull in the right people, maybe for special columns, and make sure we have the editorial board is responsible for ensuring that the quality of the content of the magazine as well as uh, the review process and make sure what we are publishing is useful to the community. If anyone is interested, we will definitely share the slides after, and you can also fill in the volunteer form, and we'll definitely get back to you about that. So yeah, again, I just wanted to give a shout out to all the great volunteers. This magazine and the great work that the chapter is doing would have been possible without them. And yeah, you can find these resources. Feel free to check out the Feed Forward magazine previous editions. We should have one coming up next month as well. I hope you guys will tune in and engage with those articles. We have author guidelines, volunteer resources, yeah, that encourage people to just get involved. Yeah, I'm more than happy to answer any questions or comments you might have.
That's great. Thanks, Dwit, for the introduction to the Feed Forward magazine. I think we have two great sessions planned for the rest of the conference. Meanwhile, if participants have any questions for Dwit, please let us know. All right, while we are all here, I can ask maybe an insightful question from the participants. Um, Based on the previous talk, we all saw how we could improve our productivity using Gen AI tools. What tools do you use in your workflow every day to improve your productivity, uh, which have emerged in the recent times? Please unmute and we can all learn from your experience.
I think I've been using ChatGPT quite a bit. Especially, I feel it's good for getting some barebone starter code, so that you can essentially improve on it. But I have seen that for the most part, it doesn't work. It saves you time in coding it out, but you still need to fix a few things. I've rarely seen a case where it just works out of the box. But yeah.
I agree. It's another task to find the bugs in the ChatGPT code itself and fix those, which is interesting. But yes, it's a good starter uh, tool that we all can use. While we have you did about the feed forward magazine and keeping the context, what are some of the author best practices that you can recommend to the folks to follow for article submission?
Yes, I mean, in terms of, I think what we have seen is uh, in terms of author guidelines, we do see a lot of interesting articles, uh, but a majority of them might fall into the category of reviews, which is it's really challenging to write an article that is 1500 or 6000 words, which can comprehensively review a field or so I feel it's much easier to, I mean, it's always interesting to pick the latest or the greatest trending topic like Gen AI or something, but I feel if we stick to the niche, I think it you can improve like the contribution a lot than having more much broader view. And given the magazine and its format restrictions, I usually feel you can't do justice in 15 words. And other than that, uh, I think the user can also, the authors can also look at the guidelines, specifically, for example, the template and just reviewing the template and making sure they're compliant with it does definitely help. And uh, we also see there are sometimes collaborations and changes that might be needed for publishing work that might be a work in progress. So it's always good to inform the publishers ahead of time and be transparent about it. And and uh, and the author also needs to make sure that again, these are all best practices that any author should follow, is you add the right kind of references to the images or the text that you use. And yeah, I think last but not the least, I've seen a lot of users that tend to uh, have a much uh, broader scope. So at the end of the day, we need to think of it as an non-technical reader, and make sure that there are enough references or context to what we are presenting to ensure that the idea or the text that you are writing gets across to a larger audience.
Great, thanks for those tips. I think it's time for the next speaker. Um, So we have Mr. Amit Dubey, who's going to talk about revolutionizing aerospace supply chain with machine learning powered digital twins. Mr. Amit Dubey is a seasoned technology leader with over 2 decades of experience in software data science industry. As a chief technology officer at DataFlux.ai and data science manager at Agilent Technologies, he has demonstrated expertise in digital transformations, cloud computing, and emerging data science technologies. Amit's career spans across roles at prestigious organizations like Agilent Technologies, Boeing, Pfizer, Accenture, Egon Zehnder, Airbus, where he honed his skills in data science, solutions, architecture, and technology consulting. Beyond his technical prowess, Amit is passionate about mentoring and developing talent, actively participating in various technology communities. He is a frequent speaker at industry events and has contributed to publications on digital innovation. In his spare time, Amit enjoys outdoor activities and is an avid photographer. His unique blend of technical depth, leadership experience, and diverse interests make him well suited to engage with IEEE workshop audience, offering insights that bridge the gap between cutting edge technologies and practical business applications. With you, I hand it over to you, Amit.
Hey, thank you. Thank you, Sumit, for the wonderful introduction. Hello, everyone. My name is Amit, and I would be speaking to you about the digital twin, which has been a concept. Let me just share my screen and let me know if you can see it. Desktop. Let me start with this. Can you see my screen?
Yes, we can.
Okay. So before I begin about the digital twin and aerospace supply chain, I want to talk about this entire discussion. I want to keep it as very engaging, as well as the idea behind this talk today is to first explain what aerospace means, then the supply chain of aerospace, and the need of digital twin. What do we mean by digital twin? And then there would be a small demo, which is very, very basic demo, and how a particular thing can be captured from a real world or physical world to a digital world, and how that information can be used for various decision making, which eventually is the purpose of digital twin. So that's the purpose. And at the end of the conversation, I would be sharing with you a case study about a certain, hypothetical aerospace company. They're facing certain situation, and I would share the entire case, and there would be a kind of a group activity for us, or maybe you can take home like an assignment for yourself, and how you can um, use the digital twin framework, which I'm going to share in this talk, to build a proposal in your organization. So I hope we'll make good use of our time, and then learn about the digital twin, the aerospace industry, and the supply chain, and then maybe kind of propagate the digital twin revolution, which is going on right now everywhere in manufacturing and supply chain industry. Okay, so let's start. So this is the most essential thing when we talk about data world, that we trust in God, but the rest all should bring data, because data is everything. To prove any decision making, to make alteration in any process, any product, everything requires data. Today's is a data-driven time. So data is essential. And on top of that sits the whole ecosystem of digital twin, or we call digital transformation. I want to make a full disclosure here because aerospace is a very sensitive technology or area in the United States. So any idea or code represented here is not taken from any aerospace firm, any manufacturing data, or from any individual. This is a presentation made only for the educational purpose and mostly gathered from the publicly available information. No FAA, ITAR data or intellectual properties used here, and all code presented here are sample work for education purpose only. So these are the compliance of the ITAR related stuff. So there is nothing secret or confidential here. Just a food for thought about the US aviation economy alone. I'm not talking about the whole world because there are major players across, Europe and China and Russia and other parts of the world, which produces, airplane and, different type of airplane. A single aircraft consists of 3.3 million parts, different small, large, big components, one airplane. Now, one production line situated in, let's say, Pacific Northwest on a large airplane company, manufacturing company, produces 45 to 60 aircraft, and there are 5 production lines. So think of it, 300, aircrafts getting manufactured by maybe 100,000 people in 1 month. So for just 60 aircraft, 180 million parts have to be gathered, collected from different, transportation means, air, ground, or, water, coming to the docking area and then getting reached to the assembly, everything getting prepared and shipped out to the customers or the, couriers. 31,000 assembly workers or machinists work in a particular company day in, day out in 3-shift, 24/7 operations. There are the airplane cost roughly about 80 million to 140 million, one airplane, depending upon the, the kind of complexity. Is it a single aisle or a twin aisle airplane? Is it or the wide body jet or a, narrow body jet? And what kind of, features or luxury you want inside an airplane, and that cost. So the airplane cost varies from 180 million to 140 million. Then there are, for each aircraft, there are 12,000 to 16,000 dedicated jobs or assembly jobs. So one assembly job requires, fixing a panel, tightening up the screw, something like that. Could be a collection of 8 to 10 tasks, and that should be performed by a dedicated, assembler or a technician. Could be drilling, could be, just fixing up seats or the internal carpet, anything like that, dealing with hazmat or painting, anything. This airplane business or economy is right now, there are 3.1 million jobs directly or indirectly dependent on US soil and giving employment to so many people all around the globe as well. At the same time, we look at the existing fleet of aircraft, 10,000 plus aircraft right now in operation for a given company, which is a US manufacturer, and in different phases of their service life. Could be 5-year-old plane, 10-year-old plane, or 20-year-old plane, or maybe end of life. Then there are that requires service, repair, so many things, changes, converting from a freighter, passenger to a freighter, refueler, so many that thing. The similar aviation industry also support space and satellite systems such as GPS, Earth observation satellites, communication satellites, international space, modules, different space travel, like Starliner or SpaceX, Blue Origin, and many others. Defense businesses, they are the backbone of U.S. defense against the adversaries. So tankers, refuelers, 100+ aircrafts right now and deployed across the world. Navy reconnaissance, 100+ aircraft carrier launch fighter planes, logistics aircraft like C-17 Glowmaster or C-5 Galaxy, so many other type of fixed-wing aircrafts, fighter planes, ground attack, aircraft such as F-18 Super Hornet or F-15, or strategic and tactical missile systems like which are used for U.S. defense, like Minuteman, or so many other missile systems which are nuclear capable, protecting the U.S. soil. The underwater system, this is also a new field right now, unmanned, underwater system, unmanned aerial systems, or we call it, a buddy for, assisting the fighter pilots in the real battlefield situation. All these components, all these products are built on the U.S. soil based on a very strong supply chain that takes about $65 billion worth of inventory, which is incoming, and $100 billion worth of finished and polished product shipping out of the United States, pushing, I think, the largest, finished product sale by dollar volume at one point. I'm not sure now, Amazon might have taken over, but I think so far the aviation industry from US was the most value generating for the US economy. This is I think we already discussed, so I don't have to go through it, but my name is Amit. I have been working almost 20 years into the different industry. My areas of interest are primarily computing, machine learning, and research on large-scale enterprise system, also integrating devices, building reports or analytics and data science, especially for the senior leadership, and how we can use different information for quick decision making. So I would be talking about the digital twin. The agenda of our talk today is, first I want to talk about what digital twin means, then the target audience who can take advantage of this conversation, then the current challenges in aerospace supply chain, and how digital twin can revolutionize supply chain fulfillment, the different use cases for digital twin, what business value, how business value is calculated. The new term right now, everybody is like going crazy about Gen AI and how the newer flavor of digital twin could be generative AI powered digital twin, and who can help to implement digital twin. So I'm not just talking about just the concept of digital twin, but the companies who can provide real tools, platforms, which can help integrate different systems and provide information on your fingertip. And then the benefits. I'll be talking about the aerospace warehouse. What is the flow of inventory in a aerospace warehouse look like, and the framework of building digital twin using that flow. How can we build, and the benefits and the challenges of building digital twin. As we know, it's a very secure technology. That means the data has to be secured from any adversary, any kind of dangerous player outside. Then I will give a little bit of demo, talk about future trends, and at the end there would be just a a small proposal discussion, and the digital thread, which is another larger context where digital twin is just a small unit of it. So I'll talk about it, and then there would be a Q&A. I'll try to wrap it up in as fast as I can, but at the same time, I want to go with a pace where everyone can understand and grasp what I'm trying to convey. So who is the target audience? So imagine a warehouse manager who wants to manage inventory planning in real time, supply chain analyst who want to resolve supply chain bottlenecks, assembly scheduler want to know installation plan, pending task, avoid delayed delivery, data scientist, applied scientist, BI analyst who want to simulate real-time SKU flow or material flow, build AI ML model for maintenance, prediction, rare event prediction, part shortages to avoid delay in the airplane delivery, inventory optimization, network optimization or route planning for moving items from one location to the other, risk planning, and then there are human resource planner. For example, everything in the supply chain world there is a human involved. So there are aspects like security, there is scheduling, making sure the job is done and it is a 24/7 operation. How can you ensure that right kind of people with the right strength available to accomplish that job without hurting the delivery, because that's costly. And then some business leader who want to know the process bottlenecks in real time. For the industrial engineers who want to improve assembly process or improve address manufacturing steps using this real-time data. So these are the people who can benefit from this talk. So this is what is a digital twin. So digital twin was first coined by Michael Greaves in 2002. He's a NASA scientist, and he wanted to have a digital replica or virtual replica of a space launch system or a space delivery system, so that he can simulate before, because in space there is no forgiveness. Anything that has gone wrong, there is no coming back from there. So he wanted to create an environment on ground where he can simulate all the problems beforehand it is launched. And that includes all the components, side boosters, engines, onboard computers, everything he wants to simulate. And as a collective picture, he wants to run this and see what problems can he see. So in short, digital twin is basically a real world physical representation of a real world physical product or a system or a process into a digital world, which can be used for simulating, monitoring, testing, integrate in the integration and maintenance. And this in real time with the advent of AI and Gen AI can be used for real-time business decision making. For example, a chip manufacturing company using digital twin wants to assess, they are launching a new chip which is 10 times or 100 times more powerful, and they want to have a simulation done that what could be the manufacturing issues, the performance issues they can face on the new chip model. So what they do is they create a digital twin first and then simulate it and then can assess before it goes into a real production. And that saves a ton and ton of cost if there is some problem. For example, you might have heard of Toyota cars. Recently, they had some issues with their airbags, and they recalled 160,000 cars without even, without causing, any. I mean, and if they would have simulated that kind of situation, they would have prevented this kind of recall, and that also create brand issues or credibility issues. that could have been solved if they would have used that same approach in their factory before shipping that product out. So that recall could have been avoided, and the effort and the cost, time, and embarrassment could have been saved. The same thing in 1991, David G has used something called mirror worlds, but it's just a very vague term for digital twin. Now, coming back to the supply chain, aerospace supply chain, the real world situation, why do we need digital twin in aerospace supply chain? So number one thing, the current aerospace supply chain faces a lot of challenges. Number one is the process has been done heavily by human beings, which is very error prone, and it has been very old and inefficient. The warehouses have been very kind of archaic, and they have just a simple dummy bread racks holding inventory with no information on how much load is there, how much inventory is there. The product demand has grown manifold. What same factory used to produce 20 aircraft in a given day is now producing 60 airplanes per month. That leads to like explosion of incoming inventory and data management, order management, inventory planning, replenishment, people management, so many things that can go wrong, and that is causing a lot of chaos. Also, decision making for these managing such large volume of inventory has been very, very inefficient. People do not have information in real time, and they cannot provide solution because they didn't know the whole picture of the supply chain or the manufacturing. As you know, one of the largest airplane company right now is struggling with quality issues. If they had this kind of solution, that would have prevented that kind of quality issues way before the model was came into physical existence. There is issues with resource planning, always level loading people, ensuring right kind of mechanics, right kind of assembly technicians, drillers. Are they available on every shift? It's not there. There's no visibility of planning affecting the quality and the production process. There's a lot of dead inventory pileup occupying space and also money. When you have dead inventory in your supply chain, which means it's not used, but it is occupying a space, which may be critical. You could have used with some active inventory, which is because there is no visibility of that particular portion is occupied. There is, despite Lean Six Sigma practices, real-time data is not available in many, many processes. So you really don't know on what area there is a gap, if there is, whether the process is efficient or inefficient, or is there a need, how we can help. That cannot be simulated in real time, and people cannot take decision. Everything is like on document or done manually. There are issues with new product development. So if every airplane development cycle takes about 10 years, and if you make a mistake, very small mistake in design, and it goes to production, it is very difficult to go back and rectify that when 400 airplanes are already sold. So it gets very difficult. Now, what if you create a mirror or a digital twin of their aircraft model, and then simulate those problems, what could go wrong, and then your product would be more mature and developed, and also it's a well-documented process. Everything would be documented while you're building digital twin. Lot of the robots or the machines that move, or carts which are moved, they are like dummy or like dumb carts which has no intelligence in it. So moving items between different locations, there is no tracking or no like efficient usage of it. The IoT or IIoT are very old. They're using passive RFID, or even ultra high frequency RFIDs, which are not secure or have a grid protection, which can be hacked. For example, a few months ago, you might have heard that a major US food facility, which provides 30% raw meat to the US market, Russian ransomware attack happened there, and they hacked the entire factory processing, and they asked for ransomware. If otherwise, they will freeze the operation of that factory. That was a critical food security flaw that happened. And this kind of thing can be avoided with having more secure and better IoT integration and grid. Emergent demand, shortage planning, inventory replenishment, route optimization. So many things are done manually on paper. I don't know why, but it is the situation right now. Majority of the even suppliers or the vendors who are supporting the supply chain also follow the same thing, which leads to massive slowness and silos and gaps. Assembly problem, resolution zones are overflowing because there is no real-time data available that how many, let's say if there is an exception occurs at the assembly area, let's say a part is broken and the job cannot be done, it is moved to a problem resolution zone. It's an area on the floor. And the supply chain manager or warehouse manager doesn't even know that there are X amount of inventory waiting for to be resolved for the problem. So there are many situations which requires real-time decision making in the process, and that's not there. These are some cases. The problem is even bigger. So to revolutionize the supply chain fulfillment process, the product manufacturing, the proposal is to have digital twin. This is a very successful approach used by many large manufacturing companies such as Siemens, Maserati, most of the European companies, car manufacturers, they use digital twin. And that's why, or some of the Japanese car makers, automakers are also using it. Some of the smaller aerospace companies, which has just a narrow body, small airplane, they are also using similar approaches. The idea is to promote this kind of technology with the advent of generative AI. It is going to be a super powerful combination to build something like that and kind of control not only the manufacturing process, but also the supply chain process and improve quality and add value. One of the key thing with this is when you monitor things real time, the process, the workflow, or the product manufacturing, the paramount thing is the people and their safety. Boeing, Airbus, Bombardier, Dassault, all aviation companies focus on the people's safety. And Go for Zero is the initiative where there should be no safety-related incident. For example, things falling on people's head, or some drill or a metal part going onto somebody's eyes, or some kind of accident happening. This can be prevented by digital twin, because you know the entire workflow. If there are gaps, you can simulate it and then address those gaps. Manage process fluctuation. Now, demand, based on demand, airplane demand, sometimes people are producing 45 airplanes, sometimes they're 60. That demand fluctuates. Now, if that fluctuates, that means the order management, fulfillment, everything has to be set accordingly. So if you have a digital twin, you can manage those process fluctuations. Then user-centric dedicated interaction. So if a supply chain planner wants to have a dashboard only focused on the process which he is working on, that also can be imitated in a virtual world. When you have digital twin, you also generate visibility and of different processes, especially for the FAA or the regulatory agencies or compliance agencies who want to see what is going on. Right now, you might have seen large airplane manufacturers are getting a lot of complaints that they have not kept the regulatory bodies or compliance bodies or authorities informed about the changes they have made. This particular solution, the digital twin, can keep not only the record keeping, but also keep everybody informed what is going on, what has changed, and since when it has changed. So that's the idea. The digital twin can help not only simulate production scenarios, order fulfillment, and so on, and scheduling, and so on. It can simulate and control design and development of new aircraft, improve product quality and reduce rework, early defect detection, and real-time insight from the factory floor usage. Manage product and component dependencies. For example, there is a larger product, then there are smaller nuts and bolts and washers and so many things which are dependent on that. So how we can create a dependent chart and how we can assemble it together, how we can store it together so that fulfilling those items is quick and those items can be delivered at the shortest possible time to the assembly area. This can also prevent manufacturing flow issues before deployment, quick root cause analysis, and proactive response to customer complaints and predictive maintenance of in-service aircraft. This is very important. Right now, this is being used by many companies where using historical maintenance data, machine learning, and AI algorithms are used to predict the in-service airplane, and they can be sent some reminders that your aircraft plane and so part number is due for replenishment or for service, and that way there are no catastrophic failures or accidents or anything like that, and maintenance is done on time. So that's one. But before we begin on digital twin, there is a need for a basic infrastructure, and that basic infrastructure on which the digital twin sits on is the digital transformation. Digital transformation means data, preparing the data, making sure it is accurate, it is governed, it is verified, and it is certified that this data we can trust. Because what is happening is there are multiple versions of data, or we can call it multiple versions of truth. In a larger company, it is very easy to see that there are two silos of data and they are not talking to each other, and which one to trust. If a leader wants to make a decision, how can we ensure that there is one single source of truth and the data is accurate and we can trust on that data? So digital transformation, information security, and data governance has to be implemented using the existing processes. I'm sure you guys are the expert in this field and know how important data is, especially in aircraft, which runs on 6 Sigma Plus. Any mistake at 30,000 feet can be lethal or dangerous. So everything has to be double and triple checked, and data has to be verified and certified. So that process, once that is done, a digital twin can be created with different purpose and context. And then the later stage, which is called digital thread, which is basically an ecosystem of data-driven architecture where different divisions or components of the entire aviation ecosystem talks to each other using that data. So using a single or common data model, in which there is one section called digital twin. You can have a digital twin for finance and accounting, for manufacturing, for human resources, for your product development, so on and so forth. And then all these digital twin can be connected using a single common model called digital thread. So that is the final stage of digital, the entire digital revolution. Any questions so far? Okay. So the next thing is, what are the different types of digital twins? There are broadly three categories I have divided. Number one is a static digital twin. For example, a cart over which the different assembly items or part numbers are hosted. It's a dumb cart which has no intelligence of its own. All we know is a cart has length, width, and depth dimensions. It has like 4 racks, can host about 300 pounds of item. That's all. It has 4 wheels. But and maybe we can stick some passive ultra high frequency or RFID, and whenever it is crossing certain zone, we can get that information. But now, let's say if you have that, we call it static, not providing too much information. But then the next revolution of digital twin came in, which is dynamic digital twin, which is now the cart is smart and has sensors. The wheels know how much load it is bearing at a given time, how many boxes it is holding. Each box is of what size. Then it is actively connected to a RFID sensors or receivers across different warehouse zones, and it is sending information every 30 seconds or every 10 seconds to the base. And this kind of thing can be used. I just gave an example of a smart delivery cart. We could use processes. For example, somebody, how's the entire workflow of the process is going on, how many items are coming at the docking station, how many trucks have been unloaded, how many trucks are emptied out, how much inventory is there on a docking station, conveyor belts, what is the load on the conveyor belts on the sorting, and then what is the status of expedited deliveries, what is the status of regular deliveries, how many items are there at the first line of warehouse, and then how much inventory are we holding on warehouse number 1, 2, 3, or whatever, and then how many carts are there on a particular zone, how many people are available for the assembly job, or getting all the items unloaded from the from the bread racks or the warehouses. What are the scheduled job for a given day or a time? All those things can be replicated. In fact, I have done that for the company I worked on, and that entire thing can be near real time. So all those devices are like some portion of it is like smart, and it's sending signal to the database, and then from database it's been read and shown on the factory floor or to the dashboards. There is the new advent or new flavor of digital twin, which is Gen AI powered digital twin, where not only you can receive information, but you can also intervene or ask questions, or stop or maybe recommend modification autonomously. So there is right now, this is under development. Some of the companies in European manufacturing, they are trying this one, is to build a LLM powered or Gen AI powered digital twin where they can control process automatically. There is no need for human intervention, or maybe just a very little need of human intervention to correct some process gaps or exceptions, process exception that are occurring. We have, I think I discussed the same situation. I mean, types, the digital twin, the static, dynamic, and Gen AI. Any questions on these? Okay. So I will talk about the other types of digital twins, like just explaining the product digital twin and the process digital twins. The product digital twin can be, for a, let's say, airplane models 737-9 or something like that. I want to, create a digital twin to assess, uh, understand the product asset requirement. I want to, use it for product usage, like how it would be used, product performance data, whether all the components are performing correctly as expected, proactive and preventive maintenance data for the product. So we can build that kind of thing. So for example, one model 737-9, I know the entire like in and out, and I have created a digital twin for that product. Now, whenever I'm deploying, I'm kind of creating and getting like telemetry data from different, um, um, wherever that airplane is flying. Right now, there is a telemetry center in like Boeing or Airbus, where they can receive data how that airplane is performing, to an extent, not all of the data, but different sensors, any malfunction, anything happening all across the globe, that telemetry is established, and using that data, usage or any kind of malfunctioning can be monitored. Process digital twin. For example, I want to create a process, the entire warehouse fulfillment flow on a virtual world, especially for a warehouse manager or a supply chain vice president who want to see what are the current gaps, issues, and um, uh, how we can improve the efficiency of the entire warehouse operation. We can also create live, real-time aerospace model assembly information. For example, there are, like I said, 12,000 to 16,000 assembly jobs. Everyone has different function and purpose. The entire thing can be simulated, and we can just click on a certain, flight line or production line, go to a specific product which is under development, and we can simulate how much has been completed, where we are stuck, and how much needs to be completed, and is there a delay in the delivery because of certain things. So those can be simulated and very well be done, because that system is getting kind of um, developed or already in place right now, and it's kind of larger companies are now more and more building such simulation, live simulation. Then transparency in inventory and operational performance. So we know how much inventory we have in hand. If we create a process digital twin, we know on X warehouse how much inventory is there for a particular part number. On Y warehouse, how much inventory we don't have, can we initiate order to replenish that inventory. So all that thing, I have built such dashboards in real time, where all the scanning, all the RFIDs, which are when the parts are arriving, scanned real time and stored in the database, and people can know on their fingertips how much inventory we have. Similarly, we can do preventive after sales airplane maintenance. Like I mentioned, this is I have already built 2 machine learning model for shortage part prediction and preventive after sales maintenance. And the other thing is the missing after investigation. So this is one specific rare event when the item is coming to the factory floor and then getting lost, because it's such a big operation, millions of parts are coming, and one bag either got loose, or the mechanic or the fulfillment staff forgot to bring it back, and it's missing, and it's not there for the assembly. And this is how can we prevent such thing, because this could cause delay in the assembly, which leads to penalties to the airplane manufacturers. So this could be another problem. And there are, installation plan prediction to allow parallel work. How can we have two assembly or technicians can work in parallel without depending on each other? So for scheduling, this is very useful using digital twin. So we can do that as well. A generative AI, powered bidirectional digital twin, like I said, a self-correcting digital twin where based on that the model has been trained for handling certain exception or process or product issues, it can send command back to the ground. And if there are some exceptions that are occurring, it can automatically ask for correction or correct it by itself if it has the authority. And that way is basically is I think is the need of the hour right now. Now that we have some digital twins where people are working on using generative AI in some of the European auto manufacturer. So this is the concept. Any questions so far before I move to the next slide? Okay. So digital twin environment in airspace is, there are a lot of sensors and, Internet of Things or devices which are planted on the ground, on the moving parts, scanners, barcode readers, sensors, load, kind of examiners, quality checker, ultrasonic sensors, which are looking for, product quality. There are vertical lift machines or robotic machines, which are moving parts here and there autonomously. And then there are replenishment teams, so many other things that has to be integrated with enterprise softwares such as data warehouses, online, with low latency to the online transaction platforms or databases, operating platforms which are faster, secure, and then those have to be connected with the BI engines or different front ends. Could be a thick client or a thin client, web-based client, or a mobile based client for information display. Then there is the hardware that which supports these infrastructure and the security protocols. We want to make sure that all the devices are secure and no malware or adversary can get access to those secure devices, because again, it's a very sensitive. Then there are different policies for compliance and legal compliance. So many things have to be implemented. So this is kind of a environment or a kind of a layers which are used in digital twin. Now, let's talk about who can help implement digital twins. There are many players who provide different types of services. Number one is the system integrators, large public companies, which are, IT enabled services, product development, my company as well. There are IT IIoT platforms, which are, of course, GE, Bosch, Siemens, and PTC, and my company also provide the small integration part. Then there is analytics. So BI engine who can use the sensor data and then show it real time in a useful format. How that can be done. Some of the modeling and simulation softwares are more complex, so there are other companies which do that stuff for you. This is, I think, I know for sure that Siemens have their own IIoT platform software. So you can support wide variety and array of Internet of Things or sensors, which you can integrate with that software, and that supports low latency data injection to the enterprise data warehouse in a secure format. Now, moving on to the airspace warehouse, how does it look like? As you know, the aerospace warehouse, if we start from the top, the parts arrive from various vendors, suppliers, and manufacturers through air, water, and ground means, and then they come to the docking and sorting facilities, and then they got dispatched to different routes. One could be for expedited delivery, one for regular delivery. There are different flows. Then there are quality inspection, that when the item comes in, there are inspector who do the making sure that all the items are correctly labeled. They are inspected. There are no integrity issues or quality issues. If there are, they have to be put into a certain location, sent back to the supplier, and new demand has to be generated. After the quality check, there is a routing to storage, which could be bread racks or smart warehouses or three-dimensional warehouses. Then we have load parts to cart and delivery to assembly area on schedule, and then return those empty carts back to the replenishment area again. So this is a cycle that goes through. This is how, like in a short, I'm just trying to showcase everywhere there are people involved. From this point onward, from here, this is like the trucks coming in to the docking station. People are unloading it, and then they are storing it into such warehouses. These are robotic three-dimensional machines with the conveyor belt having trays, 100 floor of storage, vertical storage, and automatic pick by light and ordering system. So within system or computer interface, you can just enter the part number and the machine will bring it down to you, and then you can just send it back. These are the part on this kind of carts, and then you have assembly instruments or tools which should go along with those part number. So this is called, we call it one installation plan, and combine together with it and call it standards. And then this goes to the assembly area where the mechanics start assembling one after the other based on the schedule and the plan they have been assigned to. So this is how the typical warehouse flow looks like for the airplane manufacturing. Now, what is the value of the digital twin in aerospace? We have production, less rework required, quality, you can detect defects early, you can get real-time insights, cycle time, we can do what if analysis to simulate thing before it goes to the production. Safety and compliance, you can ensure everything has been done correctly as per the FAA or the Federal Aviation Administration requirement. You can also do quick RCA, root cause analysis, before it is sent to the floor. Then there is cost versus business value. As you know, there are static, digital twin, then there is a design and manufacturing data, and then you have design, manufacturing, and operational data. And the business values you can see from left to right, the cost and complexity increases, because if you want to have more business value, you need to have more sensors, more devices, more systems in place, and then the complexity and cost will grow accordingly, but it will also give you more business value, because now you can control very fine parts of your process or manufacturing process. let's talk about the framework because we are really close to time. There are 6 steps, as you can see here, to build a digital twin. First is to identify the problem. Second is to build a plan, a platform, kind of set up an organization, find sponsors who can really like your idea and support it. Then there is alignment, make sure that your plan and framework, everything is aligned to the business requirement. You have right kind of people with the right skill set. You have partners who are willing to buy your idea and use that as a prototype in their processes. And that is very essential. And then at the last, you have execute, which is the last step where you deploy the pilot and wait for the responses and result coming in, whether people really like your idea. So these are the building blocks of digital twin and how you should build a proposal. So number one thing we'll practice this is identify and build a proposal. That's the activity we have planned after this. I'm just gonna show you a simple demo. This is just a a mechanic on the floor is trying to scan a bag or handwriting. He has written a note that particular bag has integrity broken, it's damaged, and then you can just so I just created a simple scanner. You can use RFIDs also, and so what it did is it scanned the item and it went to a database here, and you can see at 9:13 we have got the scanning done, and this scanning can be used. So I'm gonna, since we are, and this I'm using open source Spark right now, so I mean bear with me. This requires manual, but otherwise this whole thing can be automated, that the data can be ingested real time, and then you can show on a Tableau or maybe any BI application like so. And you can see here, I just
Hey Amit, sorry to interrupt. I think we're just seeing the slides. If you're sharing anything else.
one second. Okay, let me just. Thank you. Let me stop. Okay, so this is the code which I have written, and it's just a simple scanning. So this is a device. It just scanned the item, and I'm saying one more. I want to scan another handwritten item because this is how it is happening right now, and just scanned a text and saying and this data is being stored onto a database.
It's 1 o'clock.
And then I can just export this to a file. And there we have a Tableau dashboard, which you can show in real time. Okay. Now this is, I'm just, some data has been picked up because I kind of moved, but this is the data 9/13/12 it picked. And it could be in handwriting, it could be barcode, it could be just letters, and this has been shown real time. All those 3 components, which is reading from an interface, reading data, and then storing it, and then passing it on to a BI dashboard can be done near real time with very low latency. So all those three components are talking to each other, and that's what I was just I kind of just showed. This is what you can replace it with RFID, so many sensors, and like a smart card which is sending Bluetooth or so many other things. But this is just a demo of a small digital twin, very small unit of digital twin. Let's move on to, because we are nearly at time. I'm just leaving this based on the framework. This is just a case of a company, just any company, Airlink. There is a CEO. She has 25 years of experience. Her company is now struggling with certain supply chain problems and issues. There are stakeholders, and you have to build a proposal, basically, to describe the problem, possible causes, and then how can you, your digital twin solution can address that problem. Who are the stakeholders? Who should be on board, and then make recommendation whether we should go for a digital twin or not. So I will forward this to you for your thought, and I hope everybody liked this conversation. I apologize that there is no time left for Q&A, but we can do it if the time permits. Okay?
All right. Thank you so much, Amit. So now we move on to the next speaker, Dwit Chenna, who is going to talk about enabling performance efficient Gen AI at edge through quantization. Mr. Dwit Chenna is working as a member of technical staff, product development, AI inference at AMD. He is highly experienced. He is highly experienced research and development professional with focus on algorithm development and optimization in computer vision, deep learning, and edge AI. Over the past decade, he has honed his expertise in creating state-of-the-art performance-critical perception systems, particularly on resource-constrained hardware like digital signal processors. His work is centered on optimizing deep learning models to enhance efficiency and accuracy, while also addressing key performance metrics such as latency, memory usage, bandwidth, and power consumption. Dwit's career includes significant roles at prestigious organizations such as Magic Leap, the FDA Center of Devices and Radiology Health, and AMD. His contributions, including advancements in the augmented reality and non-contact fever screening, have been instrumental in solving complex real-world challenges. Beyond his technical prowess, Dwight is recognized in leader in the technology community, serving as technical committee member, reviewer for leading conferences, a judge for AI Excellence Awards, and a speaker at major technology summits. With that, I hand over to Dwight.
Hi, everyone. Thanks, Sumit, for the introduction. So let me see if I can share my screen. Can you guys see my screen?
Yes, we can.
Oh, yeah. Okay, great. So just making sure. So yeah, today I'll be talking about enabling performance efficient Gen AI at the edge through quantization. As Sumit mentioned, I have a lot of experience in optimizing deep learning workloads on resource constrained hardwares, and we'll be going through some of the basics, the theory, and also the practical applications of deploying these AI models at the edge. And I just want to emphasize that all these opinions are my own, and the best part is most of the details or the documents that I share are open source, which means they are just one click away if you want to try it out and explore. Coming to the topic on enabling performance efficient AI models at the edge, I believe this is a multifaceted problem and is definitely of interest to a lot of audience. We're here with the latest development, especially with the breakthrough of Gen AI. We see a lot of businesses and individuals using these Gen AI tools in their day-to-day lives. What it means, and also suggest some of the statistics suggest that the inference cost of these AI workloads could account for almost 90% of what we are spending on AI. What it means is with the proliferation of open source models like Llama, we are seeing more and more people who are just using these models. Maybe they fine tune them, but yeah, we see applications across fields and also the more and more usages, which means the efficiency is a very important aspect that cannot be ignored. So let's dive into the details. So in this presentation, I will just give you an overview of Gen AI and talk about some of the theory behind quantization. And we will address the transformer architecture, which forms the backbone of many of the Gen AI applications that we see out there. And in quantization, we talk about certain techniques that enable these optimizations to run efficiently. And by the end, we summarize some of our key learnings and best practices that we could take away with this presentation. So let's talk about generative AI. I mean, it's a subset of powerful AI models that can create text, code, image, or video. I mean, we have seen more and more realistic and indistinguishable uh, text or code or images being generated by these AI models, which is an essentially a big breakthrough in how we go about our day-to-day tasks. As we discussed in one of the initial panel discussions, it is not impossible that we soon have our own AI assistants that help us with day-to-day activities, including our phones, that can do some of the menial or simple tasks that we have been not been able to automate so far. And if you look back at the evolution, again, while this is not at all a comprehensive review, but these are some of the key milestones in terms of Gen AI. With the proliferation of neural networks back in 2012, then we also saw the first emergence of GANs. These were generative adversarial networks which worked to create indistinguishable realistic images to train more advanced models. And then came transformers, which essentially has a breakthrough in natural language processing with models like BERT and GPT, which uh, have been quite popular in the recent days. We also see a lot of diffusion models, which are more popular in vision or video applications. Now, the Gen AI itself is a very broad topic. While we try to cover transformers and more talk more specifically in terms of the text based Gen AI models, but the principles that we learn here are applicable to most of the Gen AI models that you see out there, because transformers, the basic architecture doesn't change, and it is applicable to various applications. So, diving in, what kind of applications? As we have seen, the Gen AI has been transforming industries. It is automating tasks that needed some creative thinking, which was assumed not possible before through any simple machine learning model. And as you can see, the applications are not just limited, but limited to just text generations, summarization. We talk about coding and optimization. So improve engineering efficiency, image generation and manipulation. We're already seeing many applications of those. Audio generation and video generation. Again, while this is not a comprehensive list, but these are some of the major applications that are getting a lot of traction. We'll be talking a lot about the models that are specifically for text generation that have been very proliferant, but we do see more and more models coming in each space and improving the usability and the overall user experience. So when we look at these Gen AI models, we need to think about how to efficiently run them. And you might be hearing a lot about how even ChatGPT or these kind of models, LLM models, are so huge that setting up the infrastructure or just the cost, if you're using some cloud provider, how these inference sessions are getting more and more expensive. So, and one of the reasons that is because the efficiency of the models can significantly be improved. So while we are running inference, if we see an opportunity to improve the efficiency by 20%, that could directly translate to savings in terms of expenses as well as power savings. The amount of power that we are spending on AI is also exponentially increasing with the wider adoption of Gen AI. So here is a simple diagram that shows LLM model size versus GPU memory size. As you can see, we are getting more and more powerful models because of their capabilities, which means while the memory or the capacity of the GPUs is not scaling at the same level. What it means is that we are bound to have a bottleneck that is limiting one of the latest or the greatest model from running on on the even the most powerful GPU. What ends up happening is we have to distribute across multiple GPUs, and so if we can figure out a way to run the more powerful models on more resource constrained hardware, we can process them locally, which means more data privacy, and we have better control on what we share with the AI models. So you can take more control in terms of data privacy as well as in terms of budget on how you are utilizing your compute resources. So as we see with more and more powerful AI models, the compute and memory intensities are increasing. What quantization provides here is being able to reduce the model size. It is able to reduce the model size by a couple of fractions, sometimes even by 4 times. And it is also able to improve compute efficiency, like how much we can get, how much compute we can get from the same hardware. And while it has these advantages, maintaining the same accuracy or the performance level of these models is still challenging, and that's what makes it a field of endeavor for many researchers to dwell into. So here is a simple example of quantization. So quantization again comes in many flavors. So what we are trying to do is we have a real value, and these could be weights or activations of an AI model. And these are essentially real float values, and we need to translate them into integer values. And once we have integer values, the integer math is much more efficient than doing a float processor. So in this case, you can think of the distribution. Based on the nature of the distribution, you can decide the parameters. So if you have a symmetric distribution that is symmetric around 0, you can map these float values to integer values using just the scale. But if you have an asymmetric distribution, you need both the scale and the offset. So the scale and offset are essentially called quantization parameters. And whenever we are trying to quantize a float distribution, we are trying to select the right scale and offset to minimize quantization noise or quantization error. And here, as you can see, it depends on the min and max of the real distribution as well as the min and max of the quantized distribution. So in case of quantized distribution, the min and max are decided by the number of bits that you use to represent the weight. And 0 point, while it's an optional metric, depending on the distribution, if it is a symmetric or asymmetric distribution, you have to select the 0 point to ensure minimum quantization error. Again, these are very basic because these fundamentals are really necessary to understand how we make algorithm choices and trade-offs later on. So as you can see, if we have a float distribution which has high variability in terms of the data, what it means is that we are essentially making a trade-off between range versus precision. That means if you have a very high R min and R max, which is much wider distribution, you might have to lose precision on the more frequently occurring elements. So again, this is where you have to have certain algorithms to find the right min and max so that you are not just a few outliers are not affecting your quantization too much, but also understand what are the distribution or the float values, be it weights or activation that are important, that you have the right precision to maintain the accuracy and maintain the quantization error at the minimum. So whenever we are trying to quantize something, we are essentially making a choice between precision and range. And we keep this essentially at the core will come up quite a few times in the presentation. So we can see how different algorithms make these choices. Again, in case of quantization, there are primarily two approaches. One is quantization-aware training, and the other is post-training quantization. In case of quantization-aware training, we already know that we want to deploy this model on a quantized hardware. So what quantization-aware training does is it introduces fake quantization nodes. And while you are training, essentially you are training the model to account for the quantization error. So the network learns to take into account this quantization error and perform better. This tend to be performing really good. If you see quantization is decreasing your accuracy, you might want to try out quantization aware training so that you train your model to take into account the error. Post-training quantization, on the other hand, assumes that you already have a trained model and tries to work with whatever we have. And this is also a popular approach because many a times quantization aware training can be resource intense and it might need large data sets that many of the users might not possess or just might not have access to. So with the proliferation of open source models, the post-training quantization has become more and more popular because you are able to use the out-of-the-box models, and with minimum compute resources, you are able to quantize them and also deploy it on your custom hardware. So let's jump into the transformer architecture. As you can see, this is a typical example of a transformer architecture which has the encoder and decoder. And any transformer-based architecture, you will find a variant of the same. And we also see on on the right side the multi-head attention. As you can see, it consists of the basic building blocks like multi-head attention, addition and normalization, feed forward, and nonlinear activations like softmax. And if you look into the multi-head attention, it again splits down into matmul, softmax, and other basic operations. So as you can see, these are, while how they are organized is unique, but these are basic matrix multiplication, feed forward layers that are not new to deep learning. So as long as we are able to run them efficiently, we should be able to see a much better performance. But what makes this unique in terms of characteristics is that transformers have an exponential growth, in the sense with the size and parameters, the compute and the bandwidth increases exponentially. This is what makes them scaling them challenging, as well as deploying them even more challenging. So as you can see, we have two categories of operations here. One is the compute intense operation, that are matmul, fully connected layers that need a very compute heavy machine. And there are other operations like softmax and add or norm, which are not compute intense. So which means if you have a really powerful GPU, and if you're trying to do softmax, it might not be the best tool in your kit to do that. So it you need a subtle balance between compute as well as memory to get the best performance possible. Here again, we delve into a little more details on how these each layers are quantized. As you can see, not all the layers are quantized to integer or int8. Some of them are still in float or FP16. And the choice has multiple factors on deciding which precision to be used for a layer. For example, operations like matmul and feed forward layers, like fully connected layers, can really take advantage of quantization because those are compute intense. And by just reducing the precision from FP16 or FP32 to int8, you are able to improve the compute efficiency almost by 4 times. So if you have a hardware that can support integer math, and you have compute intense operations, you would want to do that for efficiency. But when it comes to other layers like softmax or layer normalization, if you try to run them on quantization, there are two aspects. One is the quantization error that comes from them could directly impact the output. The second is these layers, the quantization could add an additional overhead. In more cases, more often than not, just having quantization will have additional overheads for scale conversion. If you have two inputs to an add layer, for example, and while it is not compute intense, you wanted to go ahead and quantize it, matching the scales of the two inputs is needed before you can do any mathematical operation, which means you are essentially adding more overhead to implement a simple operation like add instead of simplifying it. So this is where these approaches differ, in the sense they tend to keep more compute intense operations to lower precision and leave the more memory bound operation or not so compute intense operation in high precision to maintain accuracy as well as performance. So again, another aspect of this is granularity. So when we were talking about a float distribution, there are various ways this can be uh, grouped. For example, if you have a weight tensor, you can just take the whole weight tensor as one float distribution and try to quantize it, which will give you one scale and one offset, or the 0 point for the whole weight distribution. Or you can divide it per channel, which means you have finer granularity but more overheads. You probably have, if you have 32 channels, you might have 32 scales and 32 offsets. Another approach is maybe you can group maybe a certain number of channels. So the grouping decides how the granularity of your quantization. And this way you are essentially trading off precision versus performance. So you're trying to see how much uh, you can quantize without losing much on the accuracy, so that you still get a model that is performant and able to run on a much smaller hardware. So, diving into the techniques that we use for quantization, as we have discussed, a smooth quant is one of the popular techniques for large language model quantization. And the fundamental assumption with smooth quant is that they show that activations are much harder to quantize than weights. And the reason for that is usually weights are initialized through some Gaussian distribution. And once we start the optimization process, they still tend to keep their smooth distribution. So which means, as you can see, on the right side, the weight distributions are more less variability in them, which means, as we have discussed, we don't have to sacrifice our precision for scale. So we are able to get a very good or low quantization error. When it comes to activations, they are input dependent, and sometimes its variability can be huge. You might be training a data set on maybe academic papers, but the person who is probably entering the prompt or using it might not be using the same language as an academic journal, which means the variability has increased, which means you have to sacrifice some precision to account for that wider range of the output values. So the fundamental idea behind smooth quant is since activations and weights, we are essentially doing a multiplication. They say their idea is both have scales. And what if we can move this complexity of quantization from activations to weights? That is, this is what they call migration factor, which is they are trying to move the difficulty of quantization or the scale from activations to quantization. By doing that, they are able to balance the error between activations and weights, and they're able to get much better performance. So essentially in the smooth quant paper, that's what they propose, a scaling method to mitigate high quantization error on activation. And by getting nominal error on both activation and weights, they are able to show superior performance. And many of the large models that were not performing well with 8-bit quantization, by applying this quantization algorithm, they were able to show reasonable performance and accuracy metrics. So as I mentioned, they use the term migration strength, indicating that if it is 0, they don't do anything. It's as is. If it is 1, they're trying to migrate all the quantization error to the weights. And ideally, they have found the sweet spot between 0.4 to 5, that is trying to balance the scale or the variability between weights and activations to get the best performance. And again, this is essentially a pre-processing per se for quantization. So this can be applied with different quantization technique. This is only making the model more conducive to the quantization algorithm. So here are a few results from the smooth quant algorithm. As you can see, they're able to perform quantization of Llama 2 models uh, fairly well with a slight increase in the perplexity metric. Just to give you some primer, perplexity is essentially an accuracy metric that essentially predicts the probability of the next word and how well the model is able to predict a coherent next word. So usually the lower, the better the metric. So if you see a slight increase after quantization, that is related to quantization noise. And Wikitext is a very popular benchmark to measure these metrics. And as you can see, using a per token activation quantization and per channel weight quantization, they're able to get reasonably good results. and which was not possible before. So essentially, by applying this algorithm on shifting the quantitation difficulty between activation and weights, they were able to achieve a really good performance. And what it translates to is almost 1.5 times increase in the performance, in the throughput, essentially increasing the compute efficiency. Moving on, we next talk about activation over quantization. This is again an interesting technique where the researcher found out that if you're trying to quantize a model and the essentially there are we have sparsity in deep learning models, popularly so. Deep learning models are notoriously over parameterized so that they can converge to a local minima. What that means is you see a lot of sparsity. That means not all weights are contributing equally to the accuracy of the model, which is shown here. What they have done some evaluation studies to show that only a 0.1 to 1% of the weights, if we retain them in float precision, we are able to quantize the model without any loss, which means just 1% of the weights, if we pay more attention to 1% of the weights, we can is contributing to majority of the quantization noise. So here is an example where they try out using a few weights in FP16 and able to get recover most of the lost accuracy due to quantization. While this is interesting, the hard reality is that running the rest in int8 and only a few in FP16 is practically not possible. Many hardwares either support that or this, or if you want to do both float and int math on a single hardware, it tends to be more bulkier and expensive. So what they came up with is let's think going back to the trade-offs in quantization across scale and range. They tried to tune the quantization parameters like scale for these salient weights, the 1% of the weights. So while they suffer more quantization noise on the other weights, but they have clearly shown that they are not significant contributors to the overall accuracy metrics. So by identifying these weights, they're able to quantize better by tuning the quantization parameters to those identified weights. And one of the interesting aspects of this is also that they didn't actually base this only on the weight distribution. As you have seen, they are doing an activation aware weight quantization. That is, which weights are important is not determined by the weight magnitude themselves, but based on the activation magnitudes. So it's like a callback or a feedback kind of mechanism where based on what activations are important, they're able to identify few weights that contribute significantly to the model accuracy. So here is an example. As you can see, the initial challenge is we need to be activation aware, which means you need to be able to get some activation range, which means you need some sort of a data set, which is also referred to as calibration data set. So the user is expected to have a calibration data set that matches his use case. And through this calibration data set, they get all the activation distributions, which in turn help the AWQ algorithm identify the most important weights and use better quantization parameters to reduce quantization error in those salient weights. And AWQ has been able to achieve 4-bit quantization with 16-bit activations. So this is an approach where they instead of 8 bits for the weights, they are able to pull it down even lower to 4 bits, which is significant improvement given the fact that most of these models are huge and can't fit into a single GPU. So if you're able to quantize it from FP32 to 8-bit, you're already getting a 4x decrease in model size and bandwidth. if you're able to again reduce it to int4, you're again getting a 2x reduction in model size, which can significantly improve the performance of the model. So here are a few examples of the metrics that they show. Using AWQ on OPT and Llama 2 models, we see that they're able to generate reasonable numbers with int4. They also have an option to do int3, but int4 has been by far the most popular because of its native support. Many of the hardwares that support int8 have kernels that can support int4 math as well. And uh, clearly the 4-bit SUD has significantly better compute performance. So as you can see, we are seeing almost 4x improvements in the overall performance. This might be coming from both memory as well as compute efficiency. Another approach is block quantization. Essentially, whenever we have a float distribution, it is divided into chunks of blocks. And again, the same quantization parameters like offset and scale are determined for each block instead of a tensor or a channel. Now we are determining this for every block. And uh, we we have essentially this will enable efficient matrix multiplication as we've discussed through integer math. And the block size is essentially a trade-off. How small or how big can it go so that you trade off the overhead that is coming with it as well as the precision that you might lose. So if you have a really large block, you might have more performance because you just have very few quantization parameters to deal with, but will it be able to account for all the variability in the weights that might degrade the accuracy of the model? So again, there's always a choice on how we need to make these trade-offs in the implementation, and it also enables you to use low bit precisions which are supported by hardware to get better performance. An interesting example of block quantization is llama.cpp, which is a popular framework that implements uh, uh, that's essentially a C++ implementation of inference for Llama or Llama family of models. And they are able to explore a wide range of bit widths ranging from 8-bit to even 1.5 bits. So this kind of wide range of bit precisions allows you to tune your model and make the right kind of trade-offs for accuracy and performance for your application and your underlying hardware. Here is a typical example. While it is very similar to what we've discussed for quantization in terms of scale and offset, they have made minor modifications to make it more uh, more precise in the sense while we have the scale that is in float point, they also try to maintain the 0 point also in float. And these are some typical examples of type 0 and type 1, which can be analogous to symmetric and asymmetric quantizations. And what they do is essentially have 4-bit, 5-bit precisions to see how the model reacts to different precisions. And this is an open source implementation, and it's very widely adopted and quite popular. And it's getting more and more tractions as we see more and more adoption of open source models like Llama. And as as we have seen, quantization types, symmetric or asymmetric, uh, and they also have quantization mixes in the sense similar to the precision mixes in transformer. Not all weights and activations use the same precision. So they understand that some activations might benefit from having a few more bits so that they can reduce the quantization error. So they use a mix of 4, 8, 5-bit precisions to make sure the model does not lose the accuracy. So here is a typical example of a Q40 quantization. You determine the scale and offset based for each block. And for each block, you need to store the scale that comes with it. This is why we see fractional bits. While we are still trying to use 4-bit for the weights, but you have an overhead to maintain the offsets and the scales, which contribute to the fractional bit precision that we have seen in the previous slides. So if you're trying to use 4-bit quantization, you essentially end up with like 4.5 bits if you have a block size of 256. Next. So here is a typical example of a Llama 2 model that is running on Wikitext and Perplexity. As you can see, there is wide range of adoption from 2 bits to almost 8 bits. And if you see, the sweet spot comes down to around somewhere around 4 bits. While 2-bit precision has shown some promising results in terms of performance, but it is still not supported widely through all the hardwares and shows much higher degradation in accuracy. So 4-bit precision has been by far the most popular, showing good performance versus accuracy trade-off. And we can also see some performance metrics that are reported by the llama.cpp implementation for FP16, 8-bit and 4-bit precisions. And you can also see the corresponding decrease in model size, which enables it to run on much smaller and resource constrained hardwares. So in summary, we are just trying to understand the importance of quantization and how the efficiency of implementation is important, especially with the breakthrough of AI and the widespread adoption of Gen AI. And we we try to understand the basics of quantization so we can understand more complex algorithms better and how and why they are making certain trade-offs. And through post-training quantization techniques, we try to go over some popular techniques like smooth quant, activation-aware quantization, and block quantization, along with some results on popular models like OPT and Llama to show the effectiveness of these algorithms on real-world applications. I hope you guys found this presentation useful. I'm open to any questions.
Great, thank you, Dwit, for the great talk on this interesting topic. I don't think we have any questions in the chat here or on the YouTube live. So I think I can start some questions that I had.
Sure.
Yeah. So with the evolution of FP8 and FP4 formats, how do you think the integer quantization is relevant?
Yes. Yeah, I think we are seeing a lot of FP8 and FP4 formats, which is definitely a good sign. And while they are definitely helpful, I don't think they essentially are a replacement for integer quantization, because if you look at traditional hardware that can support float precision tend to be more bulkier and expensive when compared to integer hardware, which are tend to be more smaller and less expensive. So there is always a market. For example, DSPs is a typical example where they are integer machines and they're quite popular in very low power applications like wearables or wherever you need very power efficient implementation. So yes, I mean, I'm always excited about what's happening in the float precision, and I think it has similar challenges. But if you're trying to make a choice between FP8 and Int8, I don't think AI models are the primary cause. The primary decision comes from the hardware. And if you can get the same accuracy with a more power efficient hardware, I think it becomes a no-brainer to choose a more efficient. So as we move from FE4, I think we start to see int 4. Yeah, maybe we'll see lower precisions like even int 2. So it will all stay relevant. Yeah.
That's great. Yeah, I think that makes sense. Um, Power is a huge constraint on all these models, so definitely worth the discussion here. What do you see are the challenges in the deployment of Gen AI LLM models through quantization?
Yes, I think primarily on the deployment side, I think there has been a proliferation of hardware accelerators. Other than GPUs, we are seeing a lot of accelerators for AI inference. And I think the hardware is always trying to catch up because I think most of them had some sort of a CNN or a neural network uh, architecture. So the trade-offs for memory and bandwidth were made in mind for that. And we are seeing a sudden shift to transformers, and these accelerators are not essentially able to keep up because the bandwidth and compute requirements for transformers are uh, very different compared to CNNs or a traditional neural network. So I think that's just one aspect. So if you're not able to deploy something efficiently, which might mean that with the exploded adoption, we might see a wasted power and increased cost, which I don't think anyone would be willing to pay. But we also see that there are more LLM or transformer engines coming up. But again, we are not sure what is in stock for us for the next few years. We might have another architecture revolution, and yeah, so it's a cat and mouse, and I think the only way is to keep us informed and educated about these trends.
Hey, Dwit, this is Amit. My question to you is, um, cost is a big factor when running such models, especially, resources. This is resource intensive. Um, what are the ways a cost strapped organization can make use? What are the things they can do to, you know, um, leverage this model at the same time, keep the cost low? Do you have any recommendation for that?
So I think this is where I feel improving efficiency will directly translate into cost savings. In the sense, if you're able to reduce the model size by 1/4 and increase the compute efficiency by twice, you're essentially getting 8x gain. What it means is that the model that probably required maybe 8 GPUs or 16 GPUs to run now can take half of as many GPUs and probably get the same thing done on half the time. So, which should directly translate to a efficient implementation. So, I think one of the interesting aspects here is with CNNs, we have seen a lot of network architecture search, which are trying to optimize the models for the specific hardware and use case. So I think we need to have a similar approach where we need to understand what's the optimal model that we can use for our application and see how additional optimizations like quantization or pruning can be applied so that we are not just taking the latest and greatest model and just trying to run it. So as I said in the beginning, efficient deployment is a multifaceted problem. It's not just an AI developer or framework or hardware. They all have to come together to make it more even cost effective or efficient. So this is where I think a more systemic approach would definitely help any organization that trying to cut costs. I mean, especially on the AI inference side. If you're able to design a model that can efficiently run on your hardware and deploy it with a good understanding of your own application, I think you can save a lot more. I hope that answers your question. Yeah.
Yeah, thank you. Thank you.
All right. I think if we don't have any questions, I think we can conclude this talk. Thank you so much, Dwit, for these insights. They were certainly really helpful to all of us. We have a next session for the powers and perils of generative AI, a realistic perspective. Um, while we wait for the speaker to join, uh, does anybody on the call have any questions or comments about any of the talks we have done today so far? Take it as a no. Vishnu, do you have anything to add?
So I can probably share about the chapter. So until the speaker joins, I can probably entertain you with some of the slides. So I already introduced the chapter briefly at the beginning of the session of the event. So these are the statistics as of the 31st of March 2024. We have quite a few members. In fact, it's one of the largest chapters in the Silicon Valley section, Santa Clara Valley section itself, and probably one of the largest chapters in the world as well. So in terms of the events, we have organized quite a few events. A lot of them have been virtual events, but we also have in-person events. In-person events mainly help in networking and stuff like that. And virtual events help us get speakers from all over the world, like today. So we have a good mix of both. And we have introduced a lot of new things. So like today's event is being broadcast live on YouTube. And we do that for both in-person and virtual events. And some of the important content we also submit to IEEE TV, and sometimes they get hosted there. And we started Ask Me Anything series. We brought in world-renowned experts like Professor Pedro Domingos and Bjorn Schuller. And next month, we have on the IEEE Day, which is 1st of October, we have an Ask Me Anything series with Professor Gautam Kamath, who's a renowned researcher in the areas of data privacy and machine unlearning and stuff like that. So, so that's continuing. The AMS series is continuing. And in 2023, we also technically sponsored an IEEE Explore Index conference on cybersecurity. So that's the first time in the history of chapter we ever did that. So the proceedings are all available on IEEE Explore. And we also introduced, this is the third year of ICADS, which is the annual convention on applied data science that we are having today. And we started a podcast channel, which is very, very well received. In fact, I keep getting mails from some companies which keep track of this podcast, saying that it is one of the active podcasts. And we created company pages on LinkedIn and Facebook. So if someone is interested, they can certainly follow our updates on those pages. And Feed Forward was also introduced in the last 3 years. So these are the new happenings in the last 3 years, actually. So Feed Forward was introduced as well. And Dwit already gave a presentation on the Feed Forward magazine. We have a strong pipeline of articles. Thanks to the great efforts by the editorial committee led by Dwit Chenna. And we introduced chapter awards. Every year we have been recognizing one or more professionals, industry rising stars, and this year we have also introduced the Student Volunteer Award. So that's going strong as well. And we brought back our annual conference with in collaboration with NATIA, Taiwanese, North American Taiwanese Engineering and Science Association. So we have been having good relations with them and organizing this NFIC for 26 years, I believe. It used to, before the pandemic, it used to be in the Stanford University, and after the pandemic, we went virtual. Mostly in Stanford University before the pandemic, because it was hosted in Santa Clara University also once, I believe, but mostly in Stanford University. So during the pandemic, we could not afford an in-person event, so we had virtual NFIC for a couple of years, but we brought it back to Stanford University. And as you can see on the slide, it was very widely covered in the Chinese press about the event. And then ICADS is in its third year. We have been inviting researchers and experts from all over the world and hosting them in this conference, mini conference. And then we recently had a very well received program, 10-hour free online training for Google Cloud professionals, a professional cloud architect certification. It was co-hosted, just like today's conference, it was co-hosted by 11 other organizational units, mostly in the United States and Canada. It was attended by 41 participants, and the number of registrations were 81. We featured distinguished visitors and international speakers from various countries, like including today. And we typically had one or more events every month. So the topics included generative AI, large language models, quantum computing, blockchain, and all these cutting edge technologies. We have been celebrating IEEE Day with some event or the other. In 2023, it was a panel discussion on ethical AI. This year, it's going to be this, like I mentioned, Ask Me Anything series. We are always on the lookout for volunteers, selfless volunteers without any hidden agendas. That's more important. So we can make use of the help in various aspects of running the chapter. So please feel free to reach out. And with that, I think we have the speaker for the next talk already on the call. So I will transfer the control over to the MC, Sumit. Please take it over, Sumit.
All right. Thank you, Vishnu. That was really insightful. Yeah. So we have the next speaker, Professor Sam Murugesan. He's going to talk about the powers and perils of generative AI, a realistic perspective. Professor San Murugesan is the Director of Bright Professional Services in Sydney, Australia, and an Editor-in-Chief of IEEE Intelligent Systems. He is also an adjunct professor at School of Computing at Western Sydney University and an honorary professor at Amity University. He has extensive background in academia and industry, having previously worked as a senior research fellow at NASA Ames Research Center and holds a senior positions at Southern Cross University and Indian Space Research Organization. Murugesan's expertise covers broad spectrum of areas in information technology, including smart systems, sustainability, AI, autonomous systems, green computing, cloud computing, and IoT. He has authored and co-edited several books, including Encyclopedia of Cloud Computing and Harnessing Green IT Principles and Practices. Murugesan is a distinguished speaker of the ACM and IEEE and has recognized with numerous awards such as IEEE Computer Society's Distinguished Service Certificate for his significant contributions to the field. He is also a senior member of IEEE and a Golden Core member of IEEE Computer Science Society. In addition to his academic and research contribution, Professor has been actively involved in organizing conferences, delivering keynotes, and providing consultancy services. He holds a Ph.D. from Indian Institute of Science and MTech from Indian Institute of Technology, Madras, and a BE honors from PSG College of Technology. With that, I hand over to Professor Sand for this insightful talk.
Thank you, Sumit. Welcome, everyone. It's my pleasure to be with you all today and discuss about generative AI. I hope you are able to hear me. Can someone respond?
Yes, we can hear you. Yeah.
Okay, that's good. First, I would like to thank you, the organizers, for inviting me to give this talk. It is my pleasure to be with you and discuss about generative AI. And as you all know, and as you all recognize, generative AI is a hot topic. So it is good to look at what are the pluses and minuses of generative AI and how we can get prepared for what someone calls a generative AI era, that is years to come. So with that brief intro, I will discuss about the potential or the promise of generative AI, and more importantly, discuss some of the limitations, concerns we have, and how some of those concerns are being addressed. And also, I will highlight some of the latest advances in generative AI that will propel us further in adoption and addressing some of the limitations that we currently face. So with that introduction, let me pass on to share the screen with you and then go forward. I would appreciate the MC if give some sort of a signal just 5 or 10 minutes before the deadline of my talk so that I can try to complete it within the time. I understand that many of you are attending this online program for the last 5 years, five hours, so it will be hard to stretch it. So let me share my screen. Are you able to see my screen?
Yes, we can. Yeah.
Okay. I'll go to the full screen mode. Okay. The title of my talk is The Power and Perils of Generative AI, a Realistic Perspective. I wanted to provide a holistic perspective because when you look at the media and some of the LinkedIn groups in AI, there is a lot of discussion about what generative AI can do and cannot do. And some of the discussions are very sort of frightening, if you'd like to say. So as a professional, it is important to have a holistic perspective. That's what my objective is to give say, a realistic or a holistic perspective. As we all know, generative AI is probably the single hottest innovation during the last 2 years, perhaps late 2022 to now. I don't have to highlight to this particular audience that how I say it is hottest, because it has gained a widespread adoption, reaching even 100 million active users within just 2 months. And also it's caused intense competition among big techs and startups. Before the introduction of ChatGPT, and before it is made public by OpenAI, there were big techs were working on it, but it didn't rise the competition level and the need to bring out the new products, new services, and it increase the competition. And also, this is perhaps one of the hot topic that received extensive media coverage as well as the scientific publication and public attention. Probably, if you mention ChatGPT and generative AI, perhaps most of the public know about it, and at least heard about it. And also, it prompted significant action from the government, regulators, particularly the US, EU, and also some Asian countries. And of course, it gave rise to OpenAI. And of course, there is a lot of speculative activities going on about the potential of AI and hype and the share prices, fall of share prices, and so forth. So it is good to understand what is real, what is hype, and what is just a pure science fantasy. So it is hard to address this question in detail. Just I'll try to give just a glimpse of it. As we all know, why there is a lot of interest in generative AI is that the generative AI is different from the AIs what we had earlier, because it generates new content and it provides new possibilities. That's why there is a lot of say interest. And if you want to see perspective of generative AI, we should also look at what the traditional AI has been doing it. Basically, the traditional AI, based on the data we feed, they have been offering the predictions, or it is a forecast. So basically, if it can classify the data, it can predict the future events, and also they make some insights, like it has been used for predicting stock market trends, customer behavior, disease progression, and all that. So, but when it comes to the generative AI, since it can generate a new content, it opened up a new areas of application. So, such as art and design, music composition, content creation, fashion design and product design, process optimization, and code generation, and so on and so forth, which is drastically different from the type of the applications that the earlier machine learning models or even statistical learning models, and much before that the expert systems have been say offering it. So that raised the interest and also say opened up the new possibilities. And hence, all of a sudden, there was a greater interest because it can give rise to new innovations, and generative AI can enhance creativity. Probably it can help us in coming up with novel ideas, new designs, and new artworks, and so on and so forth. So basically, it offered opportunities for not only the IT or the technical professionals, but a quite range of different people. And also it can help in problem solving. So these are the many different new possibilities that generative AI started offering it. And also, if you look at ChatGPT as well as the other, say, generative AI models like Word and other things, they are particularly, I am talking about just text-based models. Basically, they are good at generating text and also summarizing it. I don't know how many of you are utilizing it. If you have a large text or a full article, or even the article in the PDF or an article in the, say, web. And many of us don't have time to go through, read all through that. But these generative AI models can summarize them and then give quickly a summarized version. So it helps us to keep track of the developments, but at the same time, it also gives the essence of the article. And it can help us to rewrite the articles. Suppose if you can have a draft, it can rewrite it. It does very well, as you all know this. And also it can mix and consolidate it. Suppose you have a 2 or 3 different versions of the draft, then it can consolidate and generate code. And also it can be used, synthesize, say, new drugs or new chemicals, new fertilizers, and so on and so forth. So basically it is not only a good tool, but also it is a versatile tool. It can do many things. And so I have many slides just to re-emphasize some of the concepts. So I don't have to go into the detail each one of them because many of the previous speakers would have covered it, and also you are familiar with many of them. The content creation, art and design, music composition, and also the generative AI now being used by the game developers to come up with new games and simulations and also provide virtual reality experiences. And interestingly, I came across a few articles that if fashion designers and then started using generative AI to come up with new fashion designs. So it is quite interesting how one particular, say, approach to artificial intelligence, which is the large language models, have given rise to application in many different areas for many different ways. And since the launch of ChatGPT in late 2022, several AI tools have appeared, and everyone wanted to see get a piece of the cake, and the several generative AI models come, and each say specializing on a particular area of application. Just given a few of them in the alphabetical order, and we can go through them later. And I will also make the slides of my talk available on my website, and also share it with the organizers for those who are interested in the makers of it. In many cases, I also hyperlink some of the say website links so that you can easily access them. So there are plenty of tools available and for various different applications. And this is another classification, suppose depending upon what the job you want to do, then classify some of the say popular generative application. And when it comes to use, then they are put into use in many different areas: healthcare, digital marketing, and education. It is one of the areas that has created a lot of concern as well as a lot of potential for student learning. And in the financial sector, environmental prediction, and customer support, software development, and of course, for creating art, images, and also the writing article. And also, even if you are just interested to know about something, you use generative AI to get a short summary of the article at different level of text. So the use cases in generative AI is vast. And in the following some 3 or 4 slides, I got a little specific. In the healthcare, they are expecting that generative AI models could some sort of transform or revolutionize healthcare by focusing on these 3 or more models. One is a personalized medicine. And what the researchers are looking at is that how we can use generative AI models to come up with personalized treatment plans, or in some cases, even personalized say medicine to overcome some of the diseases and optimize care and optimize care and improve the say outcomes. And the other area is that medical imaging. They can assist in diagnosis. So they have been using AI in medical medicine even before, but with generative AI models, it could help for the diagnosis much better. And of course, the other area they are now say focusing on is new drug discovery. And of course, you are all might be familiar with the entertainment and media, the new content creation. And as soon as the ChatGPT came into say market, there was a huge strike in the US by Hollywood, say writers and artists, the potential impact of that, and then there is a concern, and that has been somehow amicably resolved because it gives both opportunities and as well as it offers some risk. And the gaming industry is say using it, and the problem is that it also can be used for create deepfakes. That's the problem. So deepfakes, generative AI can generate realistic video images, videos, images, and visual effects, and some of them could be a deepfake. That is a major concern, and that's what some of the regulations trying to address that. And the marketing and advertising, it can create a personalized content, and also that's also an area of concern at the same time because it can also create personalized phishing messages. So it can increase the security threats and product design and marketing advertisements. So basically, now it gives rise to personalized advertisement, new content creation, and very soon, actually, I will show you an example how IKEA is using generative AI to create a new content for advertisements based on the time of the year and the people's sentiment and all that very quickly with reduction in the cost, time reduced. And of course, the generative model can simulate fraudulent behavior and improve accuracy of fraud detection and so forth. That is the area in which some of the financial sector, say startups, are working on it, how we could use the generative AI to detect fraudulent behavior. And the manufacturing is coming up with new products, supply chain optimization, and predictive maintenance. So those are some of the areas. And the retail and e-commerce is this one. And architecture is also coming up with a new design automation, cost estimation, and all that. And coming to the education sector, the content generation is, of course, is one matter. Learning materials, creation of these quizzes, exercises, reading materials, and so on. And it could also serve as a virtual tutor. And it could, suppose it can use some of the generative AI, say, models to come up with a new curriculum or a new course one is for giving on. So basically, it helps the teachers as well as the students. And of course, there are some areas of concern. I will discuss about that a bit later. So basically, the even legal community, legal lawyers and solicitors have started using generative AI for things like contract generation, compliance monitoring, and case analysis, and so on and so forth. Recently, there has been a recent case. I'll discuss that when we talk about the risk. And like that, there are many areas in almost in all diverse fields. The potential of AI is being realized. And I'll give one or two specific examples. The Australian Bureau of Statistics, they used ChatGPT to streamline the process of rewriting the job descriptions for the Australian and New Zealand standard classification of occupation. They classified the job into different categories. That's why this code comes through Australia and New Zealand standard classification occupations. There are about 1,770 job descriptions has to be rewritten in a new format or they need to be updated, they use generative AI, ChatGPT. They trained it specifically for this purpose. And then it helps them to save over 1,600 hours of manual work, basically to rewrite the high quality job description. According to the reports, both the developers as well as users are satisfied with the outcome. Basically, this kind of job can be done very well by, say, generative AI. This is the one example I mentioned earlier. Even generative AI used in areas that is never thought of before. Basically, Stitch Fix is a company that is using generative AI to help us to dress better. Basically, it has collected all the data from the previous the fashion designs, customized fashions, and then created a generative AI model. So, given your preferences, given your say other factors, then it can come up with a particular fashion, and then if you like it, then it go further steps, and then it gives all the required data for them to make it. So you can get the customized dress made for you using this thing. That's called Stitch Fix. And I mentioned about that how the IKEA is using. IKEA is using in two specific areas. One is as a AI design assistant for each customer. So basically, you can express your ideas or your preferences. Then it will come up with personalized design suggestions. And also it will answer questions about your product purchases. Suppose you want to redesign your house or redesign your, say, living room and what kind of furniture to use and things like that. So they have designed a system that is the AI design assistant, which each customer can make use of it and then come up various design options and product options. On the other end, they have used what is called as a AI toolbox that is basically used for marketing and advertising. So basically, they have a customized version of Microsoft Bing Copilot. So basically, it enables them to quickly create a content or come up with a new advertising material. So, for example, the coming season is say Christmas season. So, according to the say flavor of the particular season, they can create advertising materials and the arrangement of store arrangement as well as the product displays and things like that. So basically, they are using generative one on the side to assist the customer, on the other side as a toolbox for the staff to create content or reappearance. And there are a number of tools have come up specifically for the education. And here I have listed one of the recent article that lists various tools that can be used for generative or say education at different levels at schools, universities, and say and middle schools and so on and so forth. And soon after the release of ChatGPT in late 2022, myself and one of my colleagues wrote an article, The Rise of Generative AI and its Impact on Education, Promise and Perils. In that article, we outlined the various ways the generative AI could be used in education. And also, we highlighted some of the risks or the perils. It is available for free download. So I've given the link. It was published in the IEEE Computer Society magazine. And for those who are interested in pursuing further, those who are in education sector, can look at that. And it was just immediately soon after the launch of JetGPT, and probably it may not cover some of the concerns that is expressed later in the year. So, but nevertheless, it gives a good starting point those who want to use generative AI in education, both for learning as well as for teaching purposes. And on the other side, there are also other work has been say prompted or generated. What is called generative BI. BI stands for business intelligence. Basically, it uses generative AI and the analytics to deliver insights. So basically, as a front end, it becomes a generative AI. At the back end, it goes to the data analytics or business analytics. And they came up with a new name, generative BI, generative business intelligence. Basically, that takes into account the benefits or the capabilities of the formal analytics with the generative AI so that it can face the queries and then you get the insights. And also, if you want to go by case study by industry, there are say a few case studies I have listed it here. Okay, coming to impact, and there has been a lot of discussions, debates about what the impact the generative AI could have, particularly on workforce, because generative AI could automate or say minimize some of the work we do, minimize the time we spent on creating some of our work. So McKinsey estimates that by 2030, the activities currently account for around 30% of US work hours could be automated, prompted by acceleration of generative AI. And that's where some of the concern comes from sociologists. If the work can be automated, and then if they lose the job, it has certain socio-economic impacts. So that we are already seeing as well, because particularly in some of the areas, say like content creation, editing, and say creation of the images, generative AI is being used, and then it say makes some of the people's job redundant, and that is a concern. But there is as generative AI becomes more and more powerful, versatile, and say overcomes some of the limitations that currently have. It is expected that it will have a large impact on the workforce. And also the workforce has to also be prepared or skilled enough to use generative AI judiciously. That is the other side. And the IT professionals, they need to become conversant with generative AI, either as a developers or as a application developers. So that is something. And in use of generative AI, as you all know, the prompt is the key factor. How you prompt the generative AI to create things is important. And that's where there's a new field, if you want to call it as a new field. And prompt engineering is say, sort of came up the last, say, 2 years. Basically, what the prompt engineering is then is the art and science of crafting effective inputs to guide AI models to generate desired output. Because generative the AI generate the output based on the input you provide or responding to the input you provide. That input is the prompt. So how do you configure, how do you write the prompt is very key. And the field means subfield of say art and science of crafting. How do you craft effective input is very critical in effectively using generative AI. Here, I have listed a few say tips because we need to be as specific as possible. So what is your objective? We need to be very specific as possible. Suppose you are writing you ask ChatGPT to write an article, say brief article about 500 words article on cancer. So you need to be very specific and also give the context, whom it is meant for. Is it meant for the school children or is it meant for someone who has been diagnosed with cancer and then they want to know more about it. So one need to be as specific as possible. And also a desired goal, describe the goal. Describe exactly what kind of output you think, just I mentioned there, and highlight what is important for you. And describe your setting and provide context to your target audience, level of depth of level you want, and the tone you want, and experiment with the different prompt styles. This is really helpful. Suppose you want to generate a content, and rather than just limiting with one iteration, you could use many different prompts and see that it comes up with the different answers. And then either you could manually synthesize them to get a holistic say, perspective, or you can also use generative AI to summarize it. So you can also ask it to role play. So asking that whether it's good or bad, and then give your opinion and ask the comment on it. And importantly, iterate and refine it. Because when it refines it, then the output becomes better. And also you can request examples and so on. So the prompt is very, very important. And the way you prompt will give rise to the outcome of the output. Okay, that is as far as the so many of the potentials or the promises. The promises are high, and even some of them you may also consider as a hype. But what are the downsides? What are the limitations? And probably more often than not, the potential, the promises, and some of the application areas, case studies are highlighted. But rarely, then all the concerns are presented in a unified way so that we can make a, say, holistic perspective. So that's what I will try to do in the next, say, 10 or 15 minutes. And first, the summary, as a summary slide, I will highlight the few concerns, and then I will go into the detail a bit later so that you get a sort of a quick summary of what are the concerns and limitations. The main limitation is that the accuracy and validity of the responses that generative AI provides. It may not be always accurate, and also it may not always be correct, because what generative AI, it can also what they call as a hallucinate. As many of you are aware, those who are used generative AI might be perhaps by now aware that it can make up things. It may not be as a part of the input. It may not be in the, say, it is not the data on which it is trained on, but it can make up things and provide a very convincing response. So one of the major concern is that can we depend on the outcome? So the thing is that we cannot, because it can translate. It depends upon your prompt. It depends upon the data on which it is trained on, and also the subject matter. And that is one of the main concerns. It is not something for all. So it can, when it cannot say come up with the answer, it could hallucinate, particularly when it comes to data, and then the giving the examples and resources, it can. And the other concern is that with some they identified is the bias. Whether they could be biased in the outcome. So it could be because it is trained on a large volume of data. The data that has been fed to train the large language models, then the outcome could be biased. Bias could be a gender bias, or it could be a biased opinion, or racial bias. So you can ask the opinion about certain things. Yes, the outcome would be based on the data it was fed, data collected from the internet, books, and other publications. So if the opinion, what it was fed is biased, then the outcome could also be biased. Those are the two main limitations. That is, it can hallucinate. Sometimes the response could be inaccurate and it cannot be valid. And say there could be instances wherein the outcome could be biased. So those are the main limitations as of now. But what now, how do we address that? There are certain, say, measures are being taken. And in case of the both of them, they place some guardrails so that it can try to minimize the bias in the data as well as the accuracy and validity. We'll look at that bit later. And the concern is that because it can generate content very easily and quickly without any knowledge about any subject, then there is a potential for misuse and spread of false information. And many hackers, they are using the generative AI to create spam messages, false information, and so on. That is another concern because the content creation becomes easier. And also the content created becomes more realistic and then you can create a more realistic stories. So the spreading misinformation, false information, and creating a harm, chaos is easier. And also it can create a potential harmful content. And there are also ethical concerns. Ethical concern, what is used for is ethics. Is it moral to use it for this purpose? And so on. And it could aid in cybercrime, fraud, cyber attacks by creating spam messages. And also may face some legal issues around copyright that has been some cases have been going on. Since it uses the data, published data, to train the large language models, and all generative AI based on the previously fed data, then the issue of copyright has arose. So basically, it uses the copyrighted material and then provide a fair, say, outcome. Then how do we compensate for the copyright? Do they need to get the permission from the copyright holder? And so on, those are legal issues as well. So in general, this is one. That is the way in which you use generative AI is could be a concern because it be used for some malicious purposes. And the content it generates could be inaccurate that as a user, we need to verify and make sure that it is what we wanted and it is correct. That is, fact checking is necessary. So with that, I will highlight a few other say concerns. I mentioned about ethical misuses. I don't have to go into the details. And the other concern is the privacy. And what is the privacy concern is that you feed the data, you feed the prompt. Say, for example, you give a brief description about you, and then ask it to generate a brief bio based on the, say, key points you have provided, or this, say, a CV, or you give your particular situation, ask for a solution, then the data is collected by the generative AI system, and you are, say, providing a data, and then it creates a privacy concern. That's why when you use the, say, generative AI, and what data you provide, and then what is the impact that you need to consider. There are some privacy concerns. So don't share any personal information and very specific personal data. And then when you, in those cases, you can provide, say, XXX or the name of the person as a anonymous, and then try to get the privacy concern. And mentioned about the bias and fairness issue. The other is the intellectual property. And you use the content generated by say generative AI, and then who owns the intellectual property and the authorship issues, those are something bigger. Say for example, the legal question that is being addressed in different countries in different ways is that suppose you come up with a product that is generated by AI, can it be copyrighted? Or can you get intellectual property rights for that? So those are some of the changes or the issues that need to be navigated. And of course, the security risk I mentioned. And while generative AI can generate spawns and give rise to phishing attacks, malwares, and all that, generative AI itself could become a victim of security threats. Because now there have been some attempts to say threaten the security of generative AI itself by various methods. And so both the researchers and the hackers are looking at how they can create a new kind of attack that compromise the generative AI. And of course, the other concern that given rise to is the environmental impact. As you might have seen in the popular media, there are huge cries that these generative AI models consumes a lot of energy, both particularly during the training phase, and also when large numbers of millions and millions of users use it, then it consumes large energy consumption. It has an environmental impact, and that is one concern from the environmental impact point of view. That's why there are new models are coming, emerging, that reduces the energy consumption, and also a new subfield of AI called green AI, that is environmentally friendly AI coming into picture. And of course, ethical use and the regulations. How do we regulate the use of AI so that some of the risks are minimized, and then different countries are coming up with AI regulations. So I don't want to go into the details of that. So these are the challenges. And coming up to why generative AI give incorrect output or invalid output, or why large language model hallucinate, is that the reason is different from many people expect. And Gary Marcus wrote recently a post in which he discussed the difference between the cognitive errors that human make and the generative AI or the large language model hallucinate. Because people also give incorrect output, biased responses or biased perspectives. So human is not free from those kind of limitations or concerns. But they may do intentionally, they lie it, they may misremember things or misunderstand something, give their own perspectives, which is not correct, and so on and so forth. But in the case of large language models, because the way in which they are configured, the way in which they work, gives rise to hallucination. Because what they do is that basically, once you feed the large language or large data, they find the patterns, and then they come up with certain parameters, and then they come up with an outcome based on what it knows, the patterns on which it has been defined. Basically, it doesn't know anything about the truth or falsehood. They don't know the difference between truth or falsehood like a human being. They don't have really a reasoning process to guarantee that the inferences are correct. It is not going through any reasoning process. Basically, it is a probabilistic process. Basically, what do you call it? It's a wordsmith kind of thing. So you rearrange it based on the thing. So it could be incorrect. And they are incapable of fact checking in their work. So they may give some data. So basically, they are, at least the earlier models, they are incapable of fact checking. But however, the newer models, now we can ask them to give the evidence or the references. So some of the recent say generative models can provide some references for the information or the say data it provides. So the difference is that the human being do it for a different reason, but large language models, because because the capabilities are limited. The functioning is in a particular way. So that's why it could hallucinate. That's why the fact checking and then checking by the human operator, human oversight is important. And also, if you want to say explore further about why they hallucinate, why they make up the data, and you can look at some of the article which was published in Scientific American publication. And here comes another interesting questions. There are several generative AI models are there for the same purpose. For example, you take ChatGPT, Copilot, and Bard. You pose the same question, and will the result or the outcome will be the same? You give the same prompt, exactly the same prompt. You define the contrast, be as specific as possible. Then the question is that will the answer be same? And if not, why not? The answer need not be the same, and it could be different. And not only in the presentation, but also in the content as well, and in the perspectives it provides as well, it could be different. The reason is that, and I listed there a few of them, and basically it's a probabilistic generation. As I mentioned here, they generate response based on the probability distribution. And hence, since each model is different, and each model is used on a different data, and it uses a different algorithm, then the output could be different and output are different. And the influence of training data, because each of them could use a different data set. Although they may use, say, some of them common, there could be a different. And the difference in data set also makes the influence of the training data is very critical. And also there could be data discrepancies, and basically the data on which it is trained. If two models were trained on different data sets, even subtly different, not a major difference, even minor differences, it could have a totally what we call as a world view, and hence it could have a different outcome. And algorithmic difference also could contribute to the different response and the randomness and what they call as the interpretability. Basically, it's like a black box. So for many of us, we don't know what it does. So basically, it is to interpret, it becomes difficult. Why it gave this answer, why not the other answers? We can't give any rational explanation. So the point I want to make is that even though it's the same generative model, the same system by different, say, different companies, then for the same prompt, same question, it could have a different answer. So if you want to have a more, say, refined, so you could probably, for the same task, use 2 or 3 generative AI systems and then see the difference of person. And this is probably even it could be a good topic for further research. And so we know that there are potentials, there are a lot of potential, and at the same time, there are huge risks as well. So what we do next? So we need to embrace the potential, but while at the same time minimizing the risk. So it is now in the hands of stakeholders. What I mean is developers, policymakers, and the users all work together to address the challenges and prompt the responsible use of generative AI. And one comes on the use part, how do we use it? And the other is that we all work together to address some of the risks, some of the work is going on in that direction. And so I highlighted many of them, so I will say highlighted here. So I mentioned about the generative risk. So like our data system information could be attacked by, say, hackers. Generative AI also could be attacked. Then there are new kind of risk arising. And always we need to fact check and say our depends on human oversight. So we can't entirely leave it to the say model on the output, on the validity, and also generalization limits, because the outcome depends upon the data or the area on which it has been trained on. So it cannot be a totally general one. And here is another point of view. A few days ago, I came across an article and which argues why students must embrace uh, AI with caution, because they made a study, and then it says that the key reasons for resisting ChatGPT, and it says that because if ChatGPT is used in a way that they don't learn it. So basically, they take the outcome and then submit it as another assignment, or they make use of it. They don't pay attention to learn it. That is a limitation. That's what this says. So this is the downside is that it may hamper their learning abilities, their thinking abilities. That's what some of the research shows that. Basically, it depends upon, like in other cases, how they make use of it, how the student make use of it. So with that concern, now we are coming to the close of the talk. Should we use generative AI? My perspective is yes, with the caution and the human oversight. So basically, we need to take, we can, or we should, in my view, we should take a proactive stance, make use of it, understanding the limitations, recognizing limitations, and having a human oversight would help to address some of the risks and limitations. The thing is that while there is concerns are there, but the adoption is growing. Despite concern about risk and ethical consideration associated with generative AI, they are widely embraced. Of course, some use it with caution. Basically, now the need is that everyone need to say place a caution on what they use it, how they use it, and then how do they fact check it. So the transformative potential of AI is high. So basically, we discussed that it can help to optimize the process, boost the employee productivity, new product design, and so on and so forth. And now the thing is that not only the big companies like OpenAI, Microsoft, Google, and the others are keen on working on generative AI, many startups have come up, particularly in India as well as the other emerging markets. They are focusing on AI, generative AI-based products and services. And so basically it opens up new opportunities. And now there is also a concern that not every AI project is successful. And there have been many projects fail. And the RAND Corporation, they've interviewed, say, several people, the people who are experienced in data science and engineers, and then who have used the ALML project, not just to generative AI, but in general. Why they fail? Because it is appropriate to understand why things fail. They fail because they misunderstand the problem to be solved using AI. Some have the impression that AI can solve all kinds of problems. So there is a mismatch on the capabilities of AI and the problem on hand. Misunderstanding the problem to be solved using AI. And then the major problem faced is that insufficient data to train effectively. Data is not there. That is some of the areas that is hampering the further advances. And emphasizing the latest technology over solving real-world issues basically is a fancy application or fancy application of generative AI in a particular scenario, but it doesn't solve the real-world issues. And lack of infrastructure in some cases, and applying AI to problems beyond its current capabilities. So basically, it's a lack of understanding of what it can do and what it cannot do, and also lack of insufficient data to train the models. Some of the some of the causes for the failure of a project, and then they have given some of the how it could be addressed. Basically, they need to have a clarity of the goal, focus on enduring real world problems, and invest in data, and that is the quality data. Those are some of the remedial measures. And basically, this is for those who are from industry. And you want the best practices for integrating generative AI, start small. And then now you can have leverage. There are many cloud-based AI services, generative AI services from almost all cloud service providers. Make use of them and provide investment, employee training, and those are some of the things that industry should focus on. Then just I will focus on, just in the next few minutes, the major advances that is taking place. This slide says that we need to use the technology wisely and ethically. And this cartoon says that no matter how many resources you have, if you don't know how to use them, it is not going to be very beneficial. So basically, particularly in the case of generative AI, we need to know how to use it wisely and ethically. And of course, there are several career benefits of generative AI, so everyone needs to be familiar with that. And this quote is particularly very revealing. Our future is a race between the growing power of technology and the wisdom with which you use it. This is by recently Stephen King, the celebrated scientist who passed away a couple of years ago. So that is very valid here. And this is what Microsoft CEO Satya told. Technology empowers humans to do great things. You have to be optimistic about what technology can do in the hands of human beings. So this is an optimistic side of this one. So let me see what is the time now. So basically, I'll touch upon the few advances that will help us to see where it is leading to. And actually, JetGPT or the generative model is now moving from text to multimodality. So basically, it's a multimodal AI, generative AI, that integrates text, images, and other types of data. We know that we have the generative AI models that can generate images, that can generate text. But now the focus is on the new models, that is a multimodal AI that integrate text, images, and other type of data, so that you can get a more holistic response. So basically, that is becomes important in areas like law, healthcare, music, because they can feed different kind of inputs, different format, different kind of input, and then get a more sophisticated AI. That is called as a multimodal AI. That's what someone has said. GPT is dead. Long live GPT, meaning that it is taking another direction or a new direction, so it will live longer. And then there is now focus on small language models, because all the ChatGPT, Copilot, and Bard and all based on large language models. Basically, the large volumes of data, large parameters. So if you want to see that the number of parameters ChatGPT uses is JGPT-4 uses about 1.76 trillion parameters. So now the focus is on some small language models. It is based on a specific purpose, a limited use, as you hear, more specialistic one. And then it has a fewer parameters, simpler structure, faster training, and more efficient operation. But ideal also for small devices, operating on small devices, small scale servers, mobile devices, and so forth. So the other direction that is being focused on small language models. And the other area is that what they call RAG, retrieval augmented generation. There is a technique called retrieval augmented generation. Basically, it means that you have in-house data, you have a generic large language models. So basically, try to get the benefits of both fields. So as it mentioned here, basically, you make use of the large language model, but the large language model makes use of the specialized knowledge source. As is seen here in the say figure here, you have a large language model, and then you are here the knowledge sources. It could be a say proprietary information, it could be a business information or business process information. So basically, when you give a query, prompt query, so that is fed into the specialized knowledge source, and then get the sort of a context or any specific information that is again fed into the large language model, so you get an output. It's a refined output. This is called RAG, retrieval augmented. Basically, you are augmenting the say outcome by providing the input from the
Hi,
specific.
Professor. Sorry to interrupt.
Yes,
We are reaching time, so we might want to wrap up in case we run out of the Zoom meeting time restrictions.
okay, thank you. Basically, I'm able to close it now. So basically, that's what RAG, retrieval augmented generation. And very recently, 2 days ago, OpenAI came up with a new generative model called 01 family. I don't know how many of you are familiar. It is very recent, just 2 days ago. It has very some interesting and also very what do you call transparent features. Basically, they call it 01 family, and it has enhanced reasoning capabilities. That's what they have used the term enhanced reasoning capabilities. Then the thing is that they claim that it can handle unsafe prompts and avoid generating inappropriate content. So basically, it goes to a different reasoning process. That's why they call this a reasoning models for solving hard problems. And it does not come into the public usage, but it is likely to come into public use sooner. So for those who are interested in, please go through that. I have given the references. And so basically, they have two versions. One is 01 preview and 01 mini. And so basically, we are going into the new directions. And there is a LinkedIn group called Generative AI. I don't know how many of you are familiar with. That LinkedIn group claims that they have 4 million followers and members. They discuss various things and that, if you are interested. And here are the some, say, cartoons that might see. So let us transform our entire business using generative AI. I just used to write a poem about my dog, but that has nothing to do with how do they transform the entire business process. So basically, that's why some people have a misplaced understanding of the generative AI capabilities and then try to use it for all and all purposes. I have a few other slides. I will so leave it to you to see. This is about the impact. Imagine the productivity savings with AI. We could shrink my whole team just to 3 prompt engineers reporting to me. And then my CEO says that if 3 prompt engineers could do a job, why you need a manager take up of you? So, but basically, they're just showing that there are different aspects of it. So basically, that's what I say, have time to share with you. There are a lot of potential. There are risks as well. But at the same time, as the Gartner hype cycle is right, when a new technology comes, there is a lot of hype, and then adoption is there, and then people face the problems, risks, and then the researchers as well as developers come to try to address it. Then again, the adoption picks up. I think that is the where the generative AI is here, and a lot more development will take place no matter what doomsayers say. So generator will be here with us. It will be have a long life. So with that, I'll stop it. And then if there is any questions, I am happy to answer it.
Thank you, Professor Sam Murugesan, for this insightful talk. I think I've been keeping an eye on Q&A. We do not have any on either of our channels. So I think we can close the ceremony. Thank you, Professor, again. Thank you to everyone who made this conference a success. We've had an incredible day today, learning, sharing, and connecting. Special thanks to our keynote speakers, panelists, and presenters who provided insightful discussions and inspirations. Your expertise and passions have enriched our understanding of generative AI. We're also grateful to our dedicated volunteers who work tirelessly to uh, enable this conference to be a smooth and enjoyable experience. Your efforts are truly appreciated. Finally, a heartfelt thank you to our chapter chair, Professor Vishnu Pendeyala, for his leadership and guidance in organizing this event. Your commitment to our community is evident in the quality of this conference. So let's give everyone a round of applause for making this conference a memorable one. So thank you, everyone.
Thank you. Thank you.
Thank you, everyone. Fantastic.
Thanks, everyone. Well
Awesome
said.
job, Sumit. Thank you. Really appreciate your help. Thank you, Professor Vishen.
Thank you. See you in the next event.